head of something. Oh, sorry. And head of NTNU Food Forum. Thank you.
Hello, I'm Ole-Jonny Ødegaard. I'm project manager in NC Blue Legacy. I'm here to observe and learn more about sea cucumbers today.
Thank you. That's perfect.
Hello, my name is Mats Grimstad. I'm a fisherman and captain. And actually, my first trip at sea, or fishing trip, 20 years ago, we were fishing sea cucumbers. And now we are planning to pick up the glove again.
Nice having you. Thank you.
Hello, my name is Ole Erik Nordstrand, and I'm a student from UIT. And I just came here to learn about sea cucumbers and show that there's some young guys interested as well. So thank you for letting me come.
Thank you. You're most welcome. Yeah. So this is.
Hello, my name is Bjørn Tore Nystrand. I'm a researcher at Møreforsking here in Ålesund, mainly concerned about consumer-related perspectives and also for this event, consumer acceptance of sea cucumber. So I will hold a presentation later on today.
Yes, hello everybody. I'm Snorre Bakke. I'm an associate professor at NTNU, like many others here. I used to work at Møreforsking. I worked there for 12 years, working with what we call little utilized species, so crustaceans and other invertebrates, and also sea cucumbers. So I'm just as a participant here today, but my general interest in new species and particularly sea cucumbers, I'm looking forward to the presentations.
Okay, thank you.
Yes, hello, my name is Kari Lisbeth Fjørtoft. I also work at Møre Research, Møreforsking, and my main work field is research. And then I have been working a little bit with sea cucumber a long time ago. I went with Margaret to China, and we tasted a lot of sea cucumber there and made a market research. Yes.
Okay, thank you. Thank you very much. So maybe now we can pass to the digital attendees. Maybe Anna. Anna would like to start from Mare.
Hello, I'm Ana Pombo. I'm a professor in Polytechnic of Leiria in Portugal. I'm also researcher at Mare, and I have been working with sea cucumbers in the last years, species with potential to be produced in aquaculture. Thank you.
Thank you, Anna. And Anna will have a poster presentation later in the afternoon. Probably Ellen would also like to continue.
Yes, hello everybody. Some familiar faces and new ones. I'm Ellen. I work as a researcher at Gothenburg University, and I work with the red sea cucumber Parasticus travelers and for breeding and rearing, and also looking into some restoration projects for that one.
Thank you. Ivan Carrera from Spain, Euroespace.
Hi, do you hear me?
Yes, perfectly.
I'm Ivan Carrera, I'm from Euroespace, and I'm speaking about how we use the nutraceutical as the extract of the Oloturian, the sea cucumber, and how we can transform the extract in a nutraceutical, a natural drug. So nice to see you, all of them.
Thank you, Ivan. Ivan will also present the works of their company later on in the poster session. I have Bita next on my screen. Hi, Bita.
Hi, everyone. This is Bita Forghani, and my interest in sea cucumber goes back to my PhD thesis, which was on the generation of bioactive peptides with antihypertensive activities. And now I'm a researcher at Chalmers University, Gothenburg, and it would be nice to see what is the situation here in Scandinavian countries, and then I would like to pick pick this research up again and through future collaboration. Looking forward to it. Thank you.
Thank you. Nice having you with us today. Then I have Rachel Morrison from the Memorial University of Newfoundland. She's representing the group, and Annie Mercier, who couldn't join us today. They are partner of Holstein. Rachel, would you like to say a few words?
Yes, good morning. Yes, I'm from St. John's, Newfoundland at Memorial University. I'm just a master's student, but my project is working with the species Cucumeria frondosa, and I'm mostly interested in their ecology in the Arctic populations and their nutritional characteristics. Yes.
Thank you very much. I have also, I see Ridaya Baral.
Hello. Yes. Can you?
We cannot see you. Yes.
Yeah,
Hi.
yeah.
Nice to
Can you see
you.
me? Okay. Good morning. My name is Ridaya Baral, and I'm representing a company called Amofial Process Technology. We have been delivering fish meal plant on board vessels and on land for many years. And I have just been heard about this new species and the use of it into the protein resource. So today I'm here to listen to you and see if how we can contribute to this new industries and technology.
Yeah. Thank you. Nice having you with us. I will proceed with Georgios Paksimidis from FAO. Thank you very much for joining us today. It's a pleasure. Can you just say a few words?
Sure. Good morning. I'm Georgios Paksimidis. I work for the aquaculture team of the General Fisheries Commission for the Mediterranean and the Black Sea of the FAO, the GFCM. I'm here because of the interest of the GFCM in holothurian aquaculture, in the sense that it's our new 2030 strategy aims at diversifying aquaculture towards lower trophic level species, restoration, nature-based solutions, and IMTAs. And so we're really interested in holothurian farming. Looking forward to meeting.
Thank you very much. Very nice having you with us. And then I would like to give the word to Jorge Varas from Ecuador. I see you have joined us today. Would you like to say a few words about yourself and your interests in sea cucumbers? Jorge, can you hear us? Yeah, maybe some problem with the sound. Okay, maybe Tobias from Biz Seafood can say a few words about himself. And
thank you for having us. My name is Tobias Rosendal Beck. I'm representing Biz AS. We are involved in everything from catching prawns to crayfish here in Norway. And we are now looking into how to utilize more of the bycatch and the rest raw materials from the trawling industry. So we are going to have a presentation later today, and we are looking forward to networking and expanding our knowledge base on the sea cucumber segment.
Yes. Thank you very much. Very nice having you with us. I would just want to ask the colleague from Ecuador, can you hear us? He doesn't seem to hear. You have him in the list of digital attendees. Can you drop him a line and just ask, and then he can present probably later? So this is a representative from the Technical University of Manabi from Ecuador, but I'm not sure he's a new face to our sea cucumber network. So I just wanted to ask a few words out of him, but we can do this later on when we confirm. So then I will just tell to those of you who haven't been part of the previous works of the HoloSustain project, just a couple of words about the project so that you can get the idea, the basic objectives of the project. The project started in 2019. It's funded by the Nordic Atlantic Cooperation, NORA, and it is a networking project. So our main idea. Yes, well, if you want to see, there is a slide. If not, you can also see the presenters from the digital attendees. It doesn't matter. I so wanted to underline that the project is a networking project, that we have founded a cluster type platform, since we have seen that it is really important to put all our strengths and interests together in order to be able to muster up funding and lobby for the importance of the resource towards the different authorities. One of the objectives of the project is to be this cluster type platform that puts people together and makes connections, but also to organize collaborative workshops. So this is the second workshop that we are organizing. The first one was digital due to the COVID times, and it was hosted by our colleagues at Matis in Iceland. And then we also are delivering strategic guidance report to NURA at the end of the project with the innovation objectives that could be of interest to the region, so to the NURA region, Nordic Atlantic, but also we are in collaboration with different projects and colleagues from all over Europe and Canada so far, and we have been in touch also with several platforms that are of industrial interest. On the website of the project, we maintain the news about these collaborations and all events that can be relevant to sea cucumbers. And then also we have the objective of making reviews together. So we are making review articles, and we are participating in book chapters, all in line with this strategic innovation objective establishment. And then we are also trying to potentiate the commercial or market collaborations among the project partners, but also external stakeholders. Then Lars, could you change the next slide, please? Yes, you see here the project partners actually, and just to underline that all the information on the project is on the website. You can easily find everything there, and then it's kept updated. So you can have a look at the news section for any major events related to sea cucumbers, and also to there is a newsletter that is being released every 6 months by our project partner Occupy Blue Legacy. So the newsletters are also posted on the website, as well as news about companies in Europe that are producing aquacultural products or other relevant to sea cucumber information. And just 2 words about the organization of the event today. So all the workshop is being recorded so that you all are aware of it, and it will be posted for those who couldn't attend today on the website of the project later on. So please, if anybody has an objection to that, let us know. And then the digital posters and some abstracts from the presentations can go into a PDF file which we would like to call a book of abstracts, and upload it also on the website, so that it's freely accessible by everyone who might be interested in sea cucumbers and the workshop. So there is one poster session between 2:20 and 2:35 in the afternoon, coinciding with a little bit with the coffee break, but you can attend both of the posters and pick up something. Then the same posters are exposed the whole day. Downstairs, there is a huge expo wall at the Innovation Arena, so that everybody in the building can actually be aware of these works. And the digital attendees can ask questions through the chat, or by sending us with Venke an SMS. So on this slide, you can see the phone numbers. And well, we did already the round of presentation. So Venke would like just to say a few words about the safety of the building to those of you who are here.
Do I have sound? Oh, yes, I do. Hello, everyone. I'm Venke Yxneim. I'm the cluster manager at NC Blue Legacy, which is also partner in this Solar Sustain project. So I'm assisting Mira today. So I hope we get a good day, all of us. Just two things before we get started. If anyone needs internet and need to be connected, it's an open network here called NMK Guest. So it should be easy to connect there. Secondly, fire instructions. If anything happens and we need to evacuate, we all move down the stairs out by the coffee zone to the right and go down the stairs out of the building. And we all gather by the guest parking at the northwest part of the building. So that is said, but I hope we will avoid that, of course. So I think we're there. So
thank you very
let's
much.
Start.
Yes, then I would like to give the word to our first presenter for the first session, and this is Alessandro Lovatelli from FAO in Rome. So Sandro, please go ahead. Thank you. Yes. Can you hear us, Sandro? No? Okay. Yes.
Okay, can you hear me?
Yes, now yes, thank you.
Okay, I'm trying to.
Can you share it in presentation mode?
Yes, hold on a second. I'm having problem with the layout here. Bear with me. Sorry, I am too old for this technology.
Worries.
I don't understand why it's not. I seem to be stuck with the.
If you use the old informatic trick and go in and out.
Hold on a second. It seems to be blocked.
Okay, and share and unshare again.
Okay, let me unshare. Yeah. So I will share it again. Share screen. That one. Share. Oh, for some reason I cannot.
And if you try to change the slide in this mode without putting the presentation mode. Yeah. Sorry about the technique. Push F5. Sandro, can you hear me?
Hello?
Yes, now we can hear you. Our colleague from IT support is stating that maybe if you push F5.
Okay, hold on a second, because I was basically kicked out. Share screen. I'm sharing the screen now. Share.
Yes. Then we also see the window with the invitation. Yes, now it's only the presentation.
Oh, really?
Yeah.
Okay, so I will. I don't know why it doesn't appear on my screen.
We can see your slides.
Okay, so let me just go ahead like this, and
yes,
hopefully.
Yes, please.
Okay. Well, first of all, good morning. Sorry for the confusion. I'm not very practical when computers go crazy, you know. So let me introduce myself. My name is Alessandro Lovatelli. I'm an aquaculture officer here at the Food and Agriculture Organization in FAO. And I've started my career in Asia, in Southeast Asia. This is important because I was exposed to really what was sea cucumber 35 years ago. You know, what was the market for sea cucumber? What was the consumption of sea cucumber? What was the aquaculture interest in the Asian countries, especially the Chinese market? So I have been involved, and I have been the only officer here in FEO to get engaged in sea cucumber, simply because sea cucumber is an interesting product in terms of fisheries product, especially for small scale fishermen. And this is why I have in the background, my background, I have a slide with the logo of the International Year for Artisanal Fisheries and Aquaculture. And this kind of product is interesting because basically can be fished, processed relatively easily, and stored as a dried product. So that means that people can, you know, they don't have to sell fresh fish that deteriorates very quickly. They can collect, pack, retain, and then eventually sell. So that's why I got involved. And when I got involved at the beginning, I wanted to be involved in farming, in aquaculture of sea cucumber. But then I realized quite quickly that it was better to start from the capture fishery sector. And I'll get back to you in a minute why. So how do you go to the next? Okay, I'll do it by hand. Can you see the next slide? Yes, okay, thank you. So one of the first things that we did was to organize a meeting in Dalian in China in 2004, where we brought in experts basically from all over the world, or at least from those countries that we knew had done a lot of work, had a lot of interest in the sea cucumber sector. So this publication came out, Advances in Sea Cucumber Aquaculture and Management. There were 3 sessions, a session on status and resources utilization, resource management, and aquaculture advances. And the workshop actually formulated a series of recommendations, which I think are very valid today. So, I mean, if you haven't seen this publication, the link is there. Please, you know, go and you know, search for it, download it, and look at the recommendations that came out, which I think they're very strong and very valid almost 20 years later. I do have, of all the publications I will show you later during my presentation, I do have hard copies. Any one of you are interested, please, you know, go ahead and contact me. Now you see that I have underlined or written the resource management in red. This is important because what we were seeing at the time was already a lot of overexploitation of the species in different parts of the world. And so in fact, a lot of the work during this event in Dalian was focused on resource management rather than aquaculture. So what happened then in 2008, we decided, okay, I mean, we need to know more what's happening around the world. And we actually commissioned some studies in the different continents, and within the different continents or seas, we tried to actually focus on a specific hotspot. Just to mention one of them, Latin America was one of them. And obviously the hotspot at the time was the Galapagos Islands with the species that they were collecting there and exporting. This was supported, you know, by our member countries. This work was financed by one of the member countries, I believe it was Japan. And the objective was to produce technical guidelines on how to manage these resources. This publication that you see on your screen, is basically the result of this global review on the fisheries and trade. So what happened next, based on what we collected in the discussions during this particular event, we actually came out with this publication. Now, this is the publication which came out in 2010, was Managing Sea Cucumber Fisheries with an Ecosystem Approach. It provides a roadmap to guide fisheries managers in choosing the appropriate regulatory measures and management actions to sea cucumber fisheries. Basically, improving management of sea cucumber is imperative. We have seen, and I will show you as we go along, that capture fisheries along the in an increasing number of countries is dramatic, and with countries opening and closing fisheries and trying to manage a fishery which is extremely difficult to manage, because a lot of small-scale fishermen are engaged. A lot of products are collected by women, by youth. They are processed and stored in small bags and eventually traded. It's a difficult industry to fisheries to manage, and also an expensive one to manage. So in many cases, it's not a priority of many countries because it's not really generating huge revenues for the country. But it's important to manage these fisheries, and I will get back to you on that later on. So what we did after that manual was the management manual was developed and published and distributed. We organized 2 important workshops to teach fisheries officers in different parts of the world. We had one in the Pacific Ocean, we had one on the Indian Oceans, where we invited fisheries officers from countries that were interested or with already existing fisheries in sea cucumber, and we actually organized these workshops to train them how to develop a fisheries management plan. All these publications are available. I would certainly recommend you to have a look at them. So what next? This is what came next. I'm sure that many of you have copies of this guidebook. If you haven't, again, I do have copies, and I'm happy to share them, provide them to you, send them to you. This commercially important sea cucumber of the world manual came out, guidebook came out in 2012. Okay, so sea cucumbers are commercially important. I mean, of commercial importance, are distributed globally. I mean, it's from Asia to Africa to Latin America to Central America to the northern hemisphere, Canada, US, and the Northern Europe, etc. So it's important that the trade industry or trade officers are able to identify the species which are being collected and sent for 2 reasons. One is to enable countries to know what's happening in terms of traded data, traded volumes, because one of the problems with this industry is that there is very little and reliable statistical data on what is fished, how much is fished, and where it's going. Where it's going maybe is something that most of us know, but how much is going and how much is being collected is very, very difficult. And this guidebook here actually provided the identification information for 58 species of sea cucumbers commonly exploited around the world at that time. And it provides information on its biology, on its formology, on providing photographs of live and processed specimens, information on trade, etc., etc., etc. So what did we do next? After almost 10 years, we have decided to come out with a 2nd edition of this guidebook, and which is under preparation, and we are well advanced with it, and it should come out at the end of this year. Now, why did we do this? Is because the situation within the sea cucumber fisheries has not improved, actually has worsened. So at the moment, there are, that we know of, and we have identified the species, we have the information on the species, we have 90 species which are now commercially harvested from 80 countries worldwide. And we believe that there's far more countries engaged in sea cucumbers. For example, in South Africa is exporting a lot of dried product to Asia, but dried specimens are coming in from Namibia, they're coming in from Angola, they're coming in from Mozambique, etc., etc. So as you can see from the earlier slide, we had here, 58 species which were harvested commercially, and now we have 90 species harvested. Okay, so what are we questioning ourselves is whether sea cucumbers will become a novel food. I think the question there is simple. I mean, the answer is simple. Is it not already a food item? It is a food item, but where? What is the market? The market is basically one. I don't know if you see my mouse moving, but you will see that I put a big round dot in Asia, in China. That is the biggest market. China, with entry ports from Guangzhou, from Hong Kong, but this is where the bulk of the dried sea cucumbers get to. Now there are other markets, I mean, some in Southeast Asian countries, Singapore, Malaysia, Penang, where you have Asian communities. Japan, you have some markets for a specific species. You have dried products are being actually sent also to Vancouver, where you have Asian communities of Chinese origin. And then I have a little arrow on Spain, is because in the Mediterranean there has been a tradition of eating the mussel bands in this part of the world. But apart from that, sea cucumbers are not consumed in the Mediterranean at all. So let me move down to this other slide. So this is another slide. Basically, the great majority of the dried products go to the Asian market, China, but data on capture statistic is basically not available and rather difficult to obtain reliable data. We in FAO collect data for one species, which is now the Holothurian scabra, the sandfish, which is actually is the one tropical sea cucumber species which is actually being farmed. Okay, so next slide. So I'm doing all okay. So the number of fish sea cucumber species at the global level is increasing. Why? Is it only because it's a lucrative market that a lucrative market exists? I think so. That is why people are fishing these products and drying them, storing them, and then you have middlemen bringing this stuff to China because they are ready to pay quite high prices. So the next slide here is just to show you that since the first publishing of the first FAO guide book on commercial sea cucumbers, this is what came out next. I mean, these are I think something like 20 odd species that actually we have collected data and information on these new species that actually entered the market. Now, many of these species, some of them are very attractive for the Chinese market and command quite good prices. But other species in these two lists, from Mediterranean Sea to Latin America and West Africa, they were absolutely not desirable species to have in the Chinese market. They will throw them at you and say, this is rubbish. This is not what we eat, etc., etc. But how come do we see these species being fished now? Simply because the other species which commanded good prices are declining. There is basically, no more sea cucumbers. So what was a lot yesterday, it's only few today. So to feed into the Chinese market, new species are coming in that were not desirable, of low value, or being fished in areas that traditionally were not being fished. So for this other slide here, this is a recent work that FAO was engaged. We have prepared on the request of the Liberia government, a fisheries management plan for their sea cucumbers. Now, whether they're going to implement it or not, who knows? Probably not. But the problem is that Sierra Leone was a country that had a lot of artisanal fishermen, like the one that you see here. He is actually from Sierra Leone himself. that actually have moved into Liberia because there is nothing to catch from Sierra Leone. They have depleted basically everything. So they are moving in Liberia, they're fishing possibly legally or with a little bit of bakshish, provided, but they are fishing now in Liberia. And so on Sierra Leone, on one side, you have a decline of fisheries, and Liberia is still very high. So people are moving to different areas. Now, before I go ahead, I would like to mention this, and I think I'm not mentioning anything that none of you know. I mean, it's all very obvious, but holothurians provide a very important ecological services. They are detritus feeders. They feed on organic material that settles on the seabed. They bioturbate and oxygenate the sediments, and they play a key role in the dynamics of the seabed. Basically, they keep our sea sediments healthy. Now, I grew up in Kenya, exactly there, in this area of, I don't know if you see it, near south of Malindi, with a little box in the red box in the map. I grew up there, and I was like 2 years old when I moved to Kenya, and we are the family, and we are still based here. And and I remember as a child, I'm 60 years old tomorrow, and I remember as a child here, we had an amazing biodiversity of sea cucumbers, an amazing diversity. And our house is basically here on this lagoon, sitting somewhere here. And I would like to draw your attention in these two specific areas. Let me move to the next slide. Okay, this is the lagoon. It's actually, this one is not exactly this one, it's the one next to it, this photograph. This is the one that goes just south of this other one, where the photograph is. Now, this lagoon, which is called Blue Lagoon, it was an amazing sight. It was like swimming in an aquarium. For the past 20 years, it's empty. There's nothing there. All the coral has died. There's hardly any fish. And one of the things that this lagoon had was an incredible biodiversity of sea cucumbers. We had counted something like, I can't remember, something like between 20, 25 different species of sea cucumber in this area alone. Now, if you see in the circle on your right, I believe, the oval circle, you will see that area of the lagoon. That area of lagoon was extremely healthy, with corals, with a lot of fish. Now, if you walk on this area here, you will go down to your knees in mud. Basically, it's a dead area. And even on the other side, because all the sea cucumbers, which were plentiful, are no longer there. So when people say that sea cucumbers play a biological, they provide an ecological service, is absolutely true. And this is a very clear example and very obvious that if you remove them, this is what happens. Okay. So what are the consumers of, who are the consumers of the sea cucumbers? As I said, they are mainly the Asians and mainly China. Asian communities of Chinese origin in other parts of the world. So what is it that they like? This is what they like. They basically eat sea cucumber as food. And having spent almost 10 years in Asia and in China and some of the Southeast Asian countries, living and working out there, I had, and being curious about all kinds of food items, I often ate sea cucumbers. But I can tell you, at least this is the taste that in a Caucasian like me, having not lived there all my life, but if you taste the sea cucumber as a raw product, I mean, rehydrated, but you just eat it like that, it basically tastes nothing. It has no taste to it. So the Chinese will prepare their products using all kind of sauces, garlic and that together with the sea cucumber is quite nice as a product. And this is another photograph. So it's all these additional ingredients that they have that makes it tasty. Now, one thing that the Asian market or the Chinese market like is actually the texture of the cucumber when it's cracked between their teeth. It's a bit like the Italians when they eat pasta. You know, they like to have pasta al dente. You give to an Italian a pasta which is overcooked, they will be very unhappy, so to say. So this is very true with the sea cucumbers. Now, of course, eating sea cucumbers also has, you know, for a Chinese market is, you know, they supposedly are very beneficial for your health. Sometimes give you extra power, you know, whatever that is, and also it's a food item which, if you consume it, is a symbol of being wealthy, healthy, and you're able to, you know, purchase something like that. So there's a lot of image that goes behind eating sea cucumbers. Now, why is the market increasing in China? Is because communication, transportation, in general, in this huge country, within the country, is improving. So 30 years ago, these kind of products were only available along the main coastal cities, the big, large coastal cities. You know, very little was consumed internally. But now, the further you move inside the country, you know, with millions of people, they are now consuming it. It's actually getting to them. So the market will increase and will continue to increase for sea cucumbers in the Chinese market. Now, so what else? I mean, this is a photograph that was shared to me by Mercedes Wangomet, that many of you probably know. This was taken in what's it called, at the airport in Canada somewhere. And these are capsules produced by using probably the Cucumaria frondosa, which is a sessile endemic species in that part of the world. And they produce little capsules, and they recommend it, you know, to improve your health, and to take one every day. Now, I wonder, I don't know what the price is, but I wonder, you know, how many Canadians of European descent, you know, are actually using or spending their money to buy this. I'm not sure. But the thing is that in the Chinese market now, because the sea cucumbers have such a reputation, is obviously not only food. It's a functional food, traditional medicine, cosmetics, pharmaceuticals, etc. There's a lot of products that are being produced for the Chinese market, and they are luxury products. So, should we be working to get sea cucumbers on our tables? I am not quite sure if this is going to ever happen in this part of the world or other parts of the world, if it's not for the Asian markets. I mean, we in FAO have problem trying to get some African communities and, you know, some of the countries that are not traditionally eating fish to consume fish. Can you imagine? So I find it very difficult to see that, you know, sea cucumbers will be on their table in the very near future. Now, sorry, I prepared these slides very quickly, you know, this morning, in fact, so I didn't have time to prepare additional, but allow me another 1 minute on aquaculture. A lot of work has been done on aquaculture, and there is one species, which is the Japanese Astropicopus japonicus, where they produce billions of seed, and most of the culture is done in open bays or ponds extensively, and this is extremely labor consuming, but it's possible in a reality like China. When you move to tropical countries, there is a lot of interest. We have just received a request from the government of Sri Lanka asking FAO to fund a project to develop their sea cucumber industry, mainly for restocking, because what they had in terms of natural resources, they're gone. So a lot of work has been done on aquaculture of some of the tropical species, and basically the only tropical species that I know that is really being farmed is the sandfish Holothuria scabra. Now, one of the biggest farm is actually in Saudi Arabia. It's a property that belongs to the what's it called, Naqwa Group in Saudi Arabia, south of the city of Jeddah. Now, this is a company that produces almost 80,000 metric tons of shrimp. It's owned by one of the richest men in the world. And, you know, I have been trying to question, you know, ask whether they actually make a profit out of the sea cucumber. I don't know. I never got an answer. But, you know, they are able to work with this species that they consider a diversification of their production only because they have a huge financial backup. They have a very successful operation on shrimp and sea bass. So when the gentleman earlier on this morning introduced himself from, I believe he was from Iceland or something, and he mentioned that they're fishing less prawns and they were interested in new species to produce, I'm a bit concerned that, you know, that sea cucumber might not be the next species to choose from. So selection of sea cucumber as aquaculture, as an aquaculture species, has to be evaluated very, very carefully. Also because you might be able to close the cycle, you might be able to produce a lot of seed, but actually the farming is complicated. The farming is technology is complex, and the in terms of logistics, and it's a slow grower. So thank you, and sorry for taking maybe a little bit more time than I was expected to. Thank you.
Thank you, Sandro, for your presentation and for opening the discussion on the sea cucumbers today, and for your experience. Sandro will be during the whole session here, so after the end of the session we can ask questions, okay? So now just I'd like to pass the word to our next speaker, Eva Falk.
Thank you so much. I'm so happy to be here. I have already learned so much about sea cucumbers and met a lot of interesting people, so I'm very happy to be here. I will tell you about the NTNU Food Forum and how we work towards EU, and also about the different competencies needed for this area, I think. So how we get involved in sustainable food strategies, including the European ones, financing the research and innovation, and develop our policies, and European networks and platform and strategic projects. And then I will talk about our expertise, including the education and hopefully collaboration. So sustainable food, it's a global society challenge, and we have joined the forces. And I also think that most of you here are very involved in the sustainable food and having resources for the future generations. So I will take you a little back in time. 2 years ago, NTNU became member of something called the European Food Forum. We have already worked with the food policy for our students. But when the EU Parliament started this initiative to drive the policy debate for sustainable food systems, we became a member. And I became vice president in the management board and also in the steering committee. And this makes us able to influence the policies. And that I think is very valuable for us. And I didn't know that it was so easy to influence as it really is. But a few years before that, I was in the GPI. It's a joint programming initiative on healthy diets. So it's 26 nations together on problems that they cannot solve by themselves. So Norway have one representative, no, actually two, in the scientific advisory board. And it's also about food policies, but research funding as well. So it's money from the EU and also from the different research councils from these 26 nations. And then I will mention the Metrofood. It's a large infrastructure project where NTNU is involved. and our colleague Professor Turi Rustad is the Norwegian node in this, how to collaborate on the infrastructure on the food in the future, because we cannot sit with the same instruments and laboratories everywhere. So maybe we can try to share a little more. So these are the food policy, research, funding, and infrastructure. So when we had these positions, it was very important not to use only my narrow voice. I don't know so much on the food area. So we started to collect and recruit people from all over NTNU, and NTNU is big. It's 42,000 students and 9,000 employees. So it's a lot of people. So we started to recruit to get a voice into these positions. And the multidisciplinary voice. And not only the ones that are working with food today, but the ones that had knowledge and expertise that will be important in the food future. So we have recruited more than 100 experts to work to find on these solutions. And they are from Trondheim, Gjøvik, Ålesund, the NTNU campuses, and it's a multidisciplinary positioning. All faculties are involved and 25 departments or more, I think. But we have worked a lot to understand the expertise and also to describe it for each other and also for the world around us. So we ended up with these keywords. So it's about research, innovation, education, and communication for a fair, healthy, and sustainable food system. And it's not a coincidence that this is same words as used in the farm to fork strategy in EU. But it's the keywords that we used to describe our expertise. It's innovation and design, it's society and citizens, it's digitalization. We struggle a little bit to get our people in the digital area into this forum, but we succeeded. And technology and systems, health and diet, resources and food science, and sustainability and environment. And in my presentation, you can see each one of them. This has been a big job in the last 2 years, because we have discussed about what are our competencies. I don't want to use that word because it doesn't describe it sufficiently. So we have had many micro meetings, larger meetings, but we ended up with this. So I give you an example for the society and citizens, because we are involved in that also in the sea cucumber area. For example, the citizen science and consumer behavior, food culture, policies, food practices, animal welfare, food and animal ethics. So that's examples from there. Of course, the digitalization and how to use that in the new processing lines and value chains. Technology and systems. Here we also have the product development and logistics, food valorization, health and diet. The expertise in NTNU is much on the obesity and overeating, and also lifestyle diseases. But here also we place the bioactive compounds. Resources and food science. Nutritional composition. Why should we eat sea cucumber in the future, for example? Sustainability and environment. We have to calculate how this affects the surroundings, the environment. And innovation and design, of course, and here we have put the education because we didn't know exactly where to put it. So the NTNU Food Forum is like one door to collaborate with all these different positions, like the same as I've told you about, but also here we can see the EIT Food that NTNU has become a member of now. It's the Europe's largest innovation network. And it's also, of course, about the regional aspects. Here we also collaborate with the industry clusters like Blue Legacy, and also directly with the food system actors. Yeah, one more slide saying the same actually, but it was important to also do this internal communication around who we are. Should NTNU Food Forum be something for all, or should it be like an instrument that will collaborate with others? And we ended up with the last. So here is also, you can see some of the collaborators, how we group them, because it's many clusters doing a great job, like the Blue Legacy, and we have some large companies and we have small companies. So some of the clusters can be a very good form of collaboration with them, but others we are directly collaborating with larger food actors, for example, but also the municipalities and other universities and research institutions. But here you can see like one of the most important aspects is the role of the citizens. So how we worked with the NTNU Food Forum to influence in this. For example, the Farm to Fork strategy that was launched in 2020. We made a note from, or a 10 pages position paper together, all the people in the NTNU Food Forum from the different disciplines. And we went through the strategy and gave our opinion to that. But also, for example, the research calls in the Farm to Fork, where the founding is. We acted on that one, and also on the animal welfare. So whenever it comes up, things that we mean is important for us, then we respond to that, not from single researchers, but from the group. But of course, all these experts are not as active, are not very active. Some of them are just getting information and are joining when they find it relevant. Others are very active. So when we recruited these people, it was also important to know that what are the motivation, because we can have expertise, but especially in a university, I think it's important that the researchers have motivation to do a job in the different areas. So we mapped that, and this is also from the Farm to Fork strategy. So this makes us able to prioritize and see new project possibilities and global impact. Yeah, this is about the strategy, because there are many strategies. It's international, it's European, it's national, it's regional. But when it comes to the sustainability, it started much with the UN Sustainability Development Goals that for Europe went into the Green Deal. And in the Green Deal, you have different strategies that's important for the food area. One example is the Farm to Fork. Another one is the biodiversity and the bioeconomy. Those strategies are going into different action plans. And there are action plans from all this. This is an example of something called the Code of Conduct. It's for the businesses. You're signing up to work against some aspiratory goal in the EU. So NTNU were the first university to also commit to that goal, to those goals. But the strategies here are also making the research gaps, mapping the research gaps and going into the different goals in Horizon Europe, very much show our research money, research and innovation and education money will come from in the future. So this is how the strategies affect the action plans that affects the research and innovation needs and policies. So yeah, this is that we have this orchestra to play on. We learn from each other, and I'm sure that when we talk later today, we'll also learn from each other. So having different disciplines, it's very, I think, also very meaningful and motivating. And I see when I was preparing for this, I looked at the different expertise in this map, and I saw, yeah, this might be relevant for cucumber, and this one, and all of them actually. So these are from 3 of our projects that we work together. Yeah, I skip this one. So we influence the dialogue and policies, I've said that. But here is an example from the European Food Forum. Because they arrange, or we arrange, different events on topics that we don't have enough knowledge on. And these can be like the labeling reform. We will get a sustainability labeling in a few years. What should be included in that? The nutrition labeling, animal welfare legislation will be changed, and so on. So we have these dialogue meetings where we put different actors together from the parliament, from the large companies, from researchers, from organizations, from NGOs, and so on. So here are some of the events that was the first year. Pesticides, a lot about that. Packaging. And in NTNU, we have been in most of the arrangement committees of this event and also joined them and also presented in them. So now I just do like this because it's a lot of events. But what I really experience in those fora is that, for example, when they say agri-food, when they are making calls, research calls, for example, and I say, does that mean that seafood is not included? And they say, no, seafood is included. Okay, then you have to change the name because we cannot like apply for those money. And also in the policy area, it's like that. And I've been in Bilbao now on a congress, Food for Future. And I also went to the EIT food desk there and talked a little bit with them. And he talked about agri-food and agri-food. And said, does that mean that seafood is not included? No, seafood is included. So that means if we haven't been there, maybe the call text has not been adding the seafood. So that's just one example, but we have many. Now I see my time is running out. The last event we had now was on nutrition labeling again, because it will be harmonized. It will be the same labeling system all over Europe, and the key whole and the bread scale that we know in Norway will not exist in the future, we suppose. So it will be new labels. But then in the end here, I want to talk about how we engage the students in this. For many years now, we have had something we call the digital classrooms. That we as university and are involved in this makes it also relevant for the students. So the students get a knowledge and expertise that they can bring into the companies they're working on. So we are, I cannot be updated on all this. We have chosen areas and we know what's the hot topics. We know where the laws, the regulations will come for the Scandinavian countries based on the EU regulations. So we are selecting the topics so the student will learn from them. So these are examples. It's the labeling reform again, food loss and waste, food safety, and so on. So the students, they are meeting the people from EFSA or the Commission or from the research institutes in EU, so they learn what's going on now, so they are in a dialogue. And if they are not active in this dialogue, they cannot, don't let them go up to exam. The next step is that they are meeting the food actors and collaborate with them on their challenges, and they see how this fit, and then they write a semester work. Yeah, this I talked about. Yeah, we are arranging first annual Nordic Food Forum this autumn, and one of the topics is unexplored resources and novel technologies. Maybe that could be something to collaborate on. And finally, regional engagement. We know that our students will do career in Norway and in the region. So we are very involved in that and using design. Right now, we are having a project using design thinking methodology to make the different actors work together. So everyone is learning these methods so we can collaborate and understand each other. So collaboration is key, and translation of policies may be something to collaborate on. Students and education, events and debates, input for that. Knowledge and experience, input for policies, and a lot of other things. So thank you very much.
Thank you very much. So again, questions to Eva at the end of the session when we will have 15 minutes for questions. So now I would like to give the word to Jonas, who is joining from the Institute of Marine Research of Iceland, and he's part of the Bentic group of ICES, to present to us his expertise and experience with sea cucumbers. Nice to have you, Jonas.
Thank you. Can you hear me well? Or?
Yes, yes, yes.
Okay, excellent. So the title of the talk is the title you gave to it, Miroslava. So it's about assessment here in Iceland, available information and future knowledge needs. A little bit maybe tailored to the approach from the ICS, and maybe less about improving the current fishing gear. So a little bit maybe the question, how does a new fishery start? Maybe that was maybe partly answered by Alessandro earlier. And here in Iceland, there was a company that used to dry fish, salmonids and others. So, and knew how to, make a dry product that started experimental fishery in Breiðafjörður, which is one of our most kind of fertile bays in 2003. And that was close to really prolific scallop grounds where we fish Climax Icelandica. So, and Cucumaria frondosa was a common bycatch in those fisheries. So, and the fishermen knew that, you could fish sea cucumbers there. And I guess the person who started, knew about the markets and the demand in Asia. But little was landed until 2008. When fishing was initiated in the bay south of it, close to Reykjavik, in this area E. And that year in 2008, they fished 800 tons, and in all areas around Iceland, around 1,000 tons. But there are many areas in Iceland, especially close to shore, where bottom trawling is banned. And this is something that we have discussed quite a lot here within our institute. But it was always allowed to fish with a dredge. And that was partly because we were fishing scallops all around Iceland. But of course, like all bans, you can still fish with Danish sign in the bay where the fishing area E is for flatfishes, for example. So, and the regulation here is that if it's not, banned, it is allowed, a little bit like that, So that kind of paved the way for other companies kind of to explore more areas around Iceland, and we have been trying to regulate that, and I will come better into that, later in the presentations. But currently, these are our management areas of Cucumaria frondosa around Iceland, and they are labeled here. There are 8 of those labeled from A to H. And the green areas there are the VMS records in where they have been fishing. And the small blue lines are protected areas within some of our fjords, so it's not allowed to fish deep inside the fjords with the dredge. So now we have a quite established fisheries since 2008, so we are now close to 14-15 years. And we have been trying to manage that, to our best kind of, best knowledge. And like Alessandro discussed earlier, sometimes when you start, there is not so much budget around it, and you start to manage it after you reach some levels of catches. But in Iceland, there was a peak in catches in 2019 and 2018, which was almost a twofold increase from previous years. But then we had decrease for the past 2 years, and that is partly because of, or mostly because we have enforced regulations, and we are trying to circumvent. They are fishing in areas which are not regulated, but also, of course, because of COVID-19, the market in Asia just collapsed. And here in Iceland, there's a fixed number of licenses for it, and it's managed in a way that, you know, when the kind of the TSE is reached, you know, the area is closed. But like in all other kind of, you know, cases where you have deficient sea cucumbers, you know, there has been a downward trend in the Caspian unit effort, you know, seen from the logbooks. And here in Iceland, there has also been kind of modifications regarding the vessels. They have become much larger, and now most operate with this kind of 2-beam dredges, as you can see on the image there. And this is just kind of the history of the catches around Iceland. And you see this peak there in 2018 and 2019. For example, you can see in area E where we started, which is the blue color, and that kind of stretches. We have fished there, you know, all of those years in well, relatively high numbers, but other areas are also picking up, especially in the eastern part of Iceland. And sometimes, for example, you get a new color to the graph where people have been, or the boats have been expanding to new areas. And that's, for example, is the black color area H. And like in many, you know, I would show it in the slide that, you know, the Caspian definitely went quite quickly down in that area, but that was a new expansions in 2018. And since then we have kind of, you know, we have kind of tried to regulate that area, but quite a lot of the high catches in 2018 and 19 was because there was intense fishing on virgin grounds like this black area, which were unregulated at that time, and also late closures of areas when the desired allowable catch was reached. But also we have been trying to put we are advising that we should enlarge the areas, which were enforced too late and often put forward with other changes in the regulations. So some kind of the fisheries directors here or the ministry, they wanted to put many changes, you know, acting them, you know, putting them all together. So they kind of acted a little bit too late. But now all of the areas are continuous, you know, to circumvent fishing around their edges. And we are, for the past 2 years, a bill has been in the parliament that will place the sea cucumber in the ITQ system here, you know, or the quota system, so they can be transferred between both. And that's a highly political, it's quite political here in Iceland. But I think that bill might pass. Here we can see how the fisheries have been developing, or the Caspian unit effort by areas. You can see the blue areas, for example, the Caspian unit effort was increasing for the first years. Partly that could be that, you know, they're displacing the areas on new grounds within this zone. There is a learning curve, but at a given point, you know, like in most new and expanding fisheries, you will see a downward trend. And if you look at, for example, there's an arrow there to this dark gray line. It's in area G. It starts, you know, we are fishing there for one dredge. It's above 1,000 kilos over the hour. It goes quite fast down, and it has a little bit stabilized in the past years. But still, there are reasons to be concerned about this. And quite a lot of what we are doing is based on finfish and what we're known about finfish. And we have troubles with that because life history parameters are often really poorly known of the invertebrate species, and especially the sea cucumbers. And to study that is quite difficult, and we see that in published publications that it's difficult to get those answers, and they can possibly reach 25 years away. You know, it takes about 10 years to reach 25 to 30 centimeters in Canada. So these are big ifs on many of those parameters. And if you just take a conventional finfish management and assessment, you know, you need quite a lot of parameters which are impossible almost to get from fisheries like the sea cucumber fisheries. And we take part in the International Council of Exploration of the Sea, or the ICS, and there we have defined, they have defined stock categories, defining stocks, and category 1s are stock with a quantitative assessment or full analytical assessments and forecasts. And many of our finfish stock, our cod, our haddock, our saithe are all based in that. But then we go further down the categories, and many of our invertebrates, they fall into category 3, which are stocks which survey-based assessments indicate trends. And or some other indices which are used, which are available to provide reliable indications of trends in stock metrics. So, and we even have kind of further classification of stocks where we have maybe no information about stock trends, but for most of our stocks, because logbooks are mandatory, we have some kind of information of catch per unit effort, and sometimes we have added, or in most cases we try to add it in some surveys. So a little bit what we have been doing so far in our kind of methods regarding the cucumbers is we've been taking it from a framework that was, this is based on data limited methods from 2012. That is a rule called 2/03 rule. So we based our catch advice based on index ratio, and you can see it on image up in the upper right. We can actually it's almost the same graph there, because the index of those in this case of 2020 and 2019 versus the index of 2018 to 2017 was almost the same. So in this case, we're looking at catch per unit effort based on logbooks, but we are standardizing it based on a month of catch and also boats. And so we'll be looking at those indexes, how they are, and we are multiplying our former advice with the changes in that, but we have a buffer on that, So there's a buffer on that, or an uncertainty cap that we will never increase it or reduce it by less or more than 20% each year. And then we can also put precautionary buffers if we think that which is around 20%, which if we think that the stock is declining or something else is occurring. But there are other approaches available that we could use a stock which are in category 3. We could use surplus production models, or some kind of rule where we have a constant harvest, but then we need to define what that constant harvest should be based on some kind of a survey index. So this is just what we've been doing for the past 2 years now for those stocks who have long enough catch histories here in Iceland. And before that, and before my time, we tried quite a lot of things, In 2009, we kind of estimated based on limited red surveys that 10% harvest rate would be efficient. And then we tried to standardize areas with other areas where we had longer kind of catch histories, and that was then based on VMS data. But in 2020, we used these 3/2 rules, where we have this index A, like I described, which is the standard catch per unit for the last two years, and compare that to the index of previous 3 years prior to that. And we use that for the 4 areas where we had the longest catch history. So we've been working on that now for the past 2 years. And this is a little bit the index you see on the left is the raw catch per unit effort index, and then you see the index after we have standardized it. And there's a lot of troubles involved in just by using or even trying to standardize index derived from logbook data. And this is just where we stood in a recent advice, where we were advising that we should fish around 2,300 tons. In previous years, even though there was COVID, there was still quite a lot of pressure on those grounds. We advised to fish 2,200 tons, but they managed to fish around 2,000. So even with all troubles and all that, they still managed to fish, and I guess there is still a demand for them, even if the prices have gone, they have had some difficulties for the past couple of years. So we have been trying to establish the fishery independent data to start a survey. So we had a beam troll survey around Iceland, which we enlarged in 2020, and the pink dots are the stations which we added into grounds that we knew that they were fishing sea cucumbers. And we have now run that only for 2 years, and we got the overall mean numbers of cucumbers per total mile was 1,300 in 2020 and 1,327 in 2021. So we are seeing similar numbers between years. So we are quite pleased with that. But like with any service, it's still in developmental phase. So, and from that, we get some biological parameters. But still, the biological parameters are quite difficult. It's difficult to measure sea cucumbers. Anyone who tried, they know. And we've been looking at circumference, but we also take lengths. And sometimes when you put them on the measuring board, they might shrink. You put them on the board, they are 20 centimeters. They are 50 centimeters. And if you don't measure them right away, they will end up being 12 centimeters. And then the circumference is increasing. So there is a lot of problem with them. And who knows, they might even shrink between years, if you take the next year, if they haven't been fed properly. And we also looked at drain weight. So we are getting those parameters. And this is just the kind of the same area E, where we fished 340 tons in last year's. And this is our newest index. You can see the line there, the green and the black one is a little bit different methodology, how we measure it. But according to those, we should be fishing slightly more next year. The index is going a little bit up. So we should be our advice should be 371 tons. And now we have 2 years worth of survey. You see the results from the first survey in 2020. The blue lines are kind of the survey tracks. The red area is based on VMS data where we have been fishing, and then the size of it is the density. And the density between, or the mean numbers per total mile, was quite similar between those 2 years, around 1,200 animals per total miles. But there's a standard deviation is quite high between those, and yeah, so there's quite a lot of uncertainties, and also if you kind of convert that to cuts per total mile, when you're looking at the mean weights of the animal, the mean weight increased from 271 grams to 311 in the recent years. So we're a little bit kind of figuring out how we can use it and what parameters we should be using. But at the same time, there are developments in the methods that ICES is kind of putting forwards, and they have upgraded the so-called 2003 rules to so-called RFP rule. And still we have the biomass ratio, but now we have adding in something called fishing proxy. And the fishing proxy is a little bit, how does the average length relates to the MSY proxy length? And the MSY proxy length is then based on the length of first captures. You multiply that with 0.75 plus 0.25 of L infinity. And L infinity is also a tricky parameter to estimate, at least in my mind. And so we are a little bit getting more complex framework, and we are still struggling a little bit with our kind of biological parameters. So that's it's a little bit, we're trying to figure a way forward in this, because even this, again, those rules are kind of, developed for finfish species, and they are kind of encouraging nations to get more and more on data, and to measure more and to try to predict, the status of those stocks. So this is a little bit where we stand at the moment. We are not sure, what this would be the best way forward, for example, with the sea cucumber stocks. And this is just to show you, we have here, all of the areas from A to H, and then we have, this is the length-based proxy, and you can see the difference between years. We are seeing quite stable. If you look at the top 2 lines, it's coming from area A. It's quite same between regions. So there is a regional difference, in this case, in the size of the circumference. And you can see the scale goes up to 100 centimeters. That's because the largest sea cucumber had 100 centimeters circumference, which is, you know, huge. It was yeah, huge sea cucumber. So, and so we are kind of in a developmental phase with this fishery, even if we have fished it for 14 years, and we are trying to manage it and hopefully, you know, hopefully we will find a level that we can fish it sustainably. But then we have the issue of the dredges and what we are fishing. These are just some snapshot of the catches, and you can see in the figure in the upper left, you see quite a lot of soft corals. You know, the red ones is a dead man's fingers. You know, so there is quite a lot of bycatch because they are predominantly found on hard seabed, and you know, quite often, you know, 90–95% of the catch is just a clean sea cucumbers, but in some cases, you know, sometimes half of the catches are something else that we don't want to fish, and this is maybe going to be our kind of greatest headache, you know, to figure out, because I think other capturing methods are going to be tricky in this really hard and complex bottom. So we are kind of working our way to that, and a little bit maybe to a couple of discussion points, you know, that you know something about the cucumbers, but there are recent publications that, you know, that that are suggesting that they are quite mobile, you know, and this is a paper by Hamel and Mercier and others, and where they show that they can move up to 90 kilometers per day. So, and we have kind of put our management areas all around Iceland, so we couldn't even think, you know, could they even move between those areas? And that's maybe something that we could answer a little bit with to study the genetic variation between those areas. And there's the image there to show you a little bit, you know, we have been looking at this Caspian effort from logbooks. Here we have an example of area H, which was the black line in the first slides, you know, where we fished quite a lot in 2018. In August, they were fishing in the green areas. They fished 1,400 kilos per hour. In September, a month later, they were fishing in the red areas, still within the same areas, but you can see there's a displacement. They are kind of, and most likely they have over-harvested the green areas and they're moving northwards. You know. So they are, and to track that is quite difficult. You know, you're looking at the Caspian effort from the same areas, but they are displacing their effort on relatively small scale. So, and like has been shown here in previous slide, you know, that the world history of sea cucumbers is of a sharp increase and fall in most or all regions. But it has been fished here for 15 years. And we have seen, like, you know, other areas, you know, Caspian has decreased. And new areas show rather quickly sign of utilizations. We have uncertainty in our biological parameters and also the environmental impact of the fisheries, and we need to map the bycatch much better. And we need to figure out what basic life history parameters we should use if we're going to follow the new ICES guidelines. And we should maybe even start to think about something, you know, from the commercial fleet for that. But we are quite happy with the results from a new survey, and that could maybe use in the future for maybe some other methods like the proxy method, or used in a stock production model, or like a split model. So we are, at the moment, we are working on the data, and we're going to update our assessment 15th of June, like with many other stocks here in Iceland, as the new quota year starts in 1st of September.
Sorry, Jonas, 1 minute left because
yes,
we are.
I'm finished.
Oh, thank you. Sorry. Thank you very much. Questions again will come to all the presenters in 10 minutes. And now I give the word to the last presentation by our colleague Jan.
Thank you. I've been given the honorable mission of doing the last presentation before the lunch, so I'll see if I can manage to keep your attention. But I'll try and stick to the time. Sorry. It's about aquaculture prospects for our species in the North Atlantic. There's been some talk about aquaculture already, which I found was interesting. So and also the talk from Jonas now was interesting, and it's of relevance for what I'm going to talk to as well. Why do we want to do sea cucumber aquaculture? Well, there's a demand. First of all, it's a market demand. It's still a small part of the global supply, 20 to 30%, and it's mainly Apostecopus japonicus in Asia that's being farmed. Some of the Holoturia scabra as well. Yeah. And why? Well, demand seems to be bottomless, and you heard some of the explanations there from the first presentation today. But there's severe pressure on the wild stocks, and there's an overexploitation all around the world, basically. It may even look like there's could be an overexploitation here as well in our part of the world. But it's expected that aquaculture will be an increasing part of the total supply in the future. What happened? But these sea cucumbers, why would you do aquaculture? It was mentioned restocking of natural populations, but they are also interesting as potential deposit feeders, especially the deposit feeding sea cucumbers in integrated aquaculture systems. And it's an add-on to existing aquaculture, where you could get a high price, you know all about that, product diversification. Yeah, so which are our species here? We can call them the North Atlantic species because they are found all the way up to the Arctic. It's the red sea cucumber, Parasticopus tremulus, which we have the most experience with, and it's the orange-footed sea cucumber, Cucumaria frondosa, which Jonas was just talking about. There is a commercial fishery of Cucumaria frondosa. There's no commercial fishery of red sea cucumber. It's only available as bycatch. Møreforsking has been working with the red sea cucumber since 2004, and Margaret Kjerstad, who is here now from Seafood Norway, she was very active in that when she worked for Møreforsking, and we have had projects along the entire supply chain, regional, national, international projects. Currently, we have a project with South Africa, a bilateral project, and then also a bilateral project with China. We have been doing aquaculture research since 2016. And that's mainly me and Gida here, who had a talk last year about spawning results, and also Ingebrigt Bjørkevold, who's not here, maybe attending electronically. Yeah, it's very important to emphasize this. At present, there's no commercial aquaculture of either of these species. And who knows what will happen with that. But people do research in any way. It's important research with aquaculture focus. Me as an aquaculture person thinks that's important, both on the Cucumaria frondosa and lately also on the Parasticopus tremulus, where Norway and Sweden are involved. Yeah. There are some studies from the research groups in Canada, especially on the Cucumaria frondosa in aquaculture context. Yeah, so what challenges are related to cultivation of our species? And it was mentioned in the first talk today that they are slow growers. If possible, our species are even slower growers, so because they're living in very cold waters. So that's, of course, a big bummer if you want to do aquaculture. There's very limited knowledge on the population, on the abundance of the resource, and genetics, etc. And there's limited knowledge on the fecundity and recruitment. And these are important parameters also when doing aquaculture. Yeah, because we need to know in aquaculture, we want to do the production as efficiently as possible. So we need to know, for example, tolerance to higher temperature, which we expect will give a higher growth rate, etc., etc. Yeah. So which parameters are of importance when you do aquaculture research? Well, we need data on growth, temperature tolerance, nutrition requirements, time to market size. Of course, I'm skipping spawning here, but that's of course the first step that you have to find out, closing the life cycle, which in our definition would mean getting the broodstock to spawn and growing them again to maturity and make them spawn again, all this entire cycle in captivity, which with this species could take quite some time. Yeah. This is the time to market size is, of course, if you're interested in this as a commercial venture, then it's very important for potential investors to know how long they have to wait for the return of their investment. Yeah, here are some pictures of the Cucumare frondosa and some larval stages as well, just to give that species some attention as well, since we're not working on it personally. Yeah, what have they found out about the frondosa, for example, from the east coast of Canada? It was mentioned by Jonas actually in his talk that they take a long time to reach maturity, and they are slow growers. Here we can see this the first graph there that's split into two is the first early stages, 25 months, and then they are put into the sea, and after that they are reaching sexual maturity after 35 months in the sea. So of course this is a long time if you want to do aquaculture here. So yeah, between 10 and 25 years to reach market size for frondosa. I don't know. That's a long time. But these are, of course, under natural conditions, which you would expect it to be able to speed it up a bit if you do it in tanks with the correct nutrition, etc. Yeah. The right graph is showing what happens when you try to put them out as an extractive species in an effluent from a salmon farm. This is the frondosa, that is a filter feeder. It's not the sediment feeder like the tremulous. And as you can see, the black graphs, they are showing a decrease actually in size. So it seems that it's not a complete solution for, it's not such an ideal species maybe for IMTA systems. And there was also found a big difference in wild population individuals of the same size. They had a larger organ indices, and they seem to be, what can you say, healthier than the ones that were kept in the effluent. So yeah, I don't know. Again, and again, Jonas was mentioning how measuring sea cucumbers can be a fun experience. Here is a little bit of results from our studies. We have had small individuals, as you can see, between 60 and 75 millimeters on the start there. We had them in tanks for 1 year, giving them food in excess. Of course, the food is not ideal, but it's an algae mixed sargassum as well as sand. And well, we can measure some growth during some periods, but it seems like it's very variable. And of course, again, it's a methodological difficulties here because we cannot kill the animal and measure the body wall weight at each point here. So we are sort of limited to measuring the weight and the length, and they contract, they expand, they contain various amounts of water. So it's a fun exercise. So we still keep these animals alive now, and we hope that we can get them to grow a little bit faster. We're going to give them a different feed. We just started with that last month. And we keep them for another year and see how they do. So during some periods here, we measured 0.2, 0.3% growth rates, but then again, negative growth through certain periods. So if we are optimistic, we can say that perhaps they can reach commercial size after 5 years, but this might be very optimistic. Yeah. We also put sea cucumbers in cages underneath salmon farms, and they seem to be doing well. They seem healthy, but again, it's a problem with measuring any weight increase. You see an increase in spring and a decrease in autumn, and the same we saw in here in the lab as well. It was from we can see the difference here. This is the unfed group, the bottom blue line there, and the 3 other ones are the fed groups. So you see a difference in the summer months, and then it becomes a little bit more uncertain what happens in the autumn, winter. So we saw the same similar trend when we put them in under sea cages. Yeah. Then they are feeding on the sediment, the particulate matter that falls down from the fish. Yeah. Yeah. What possibilities do you have if you want to do aquaculture? Capture-based aquaculture. You can catch these animals and feed them to get a bigger size, better price. Maybe not the way to go here. Intensive aquaculture, hatchery production is important. If you want to do restocking, if you want to do anything, you need the hatchery production up and going. Sea ranching might be an alternative, co-cultivation with other species, but the most interesting one is perhaps the integrated multi-trophic aquaculture systems, where they feed off detritus or waste from other species. And this could be land-based or sea-based. So, what do we know here? This is the life cycle. You have the mature adult spawning, you get embryos, larvae, planktonic larvae, then they settle, benthic larvae, and they grow into juveniles, and they again become adults. We know a lot about the right-hand side of the circle. In our lab, we have managed to, through the planktonic stage, but not the benthic stage. I know the Swedish Gothenburg have gotten some larvae to settle, but we don't know much about the left-hand side here. But again, we have been successful in getting hatchery production up and going. And this is of course the first step that we have to do. So is it possible to do integrated multi-trophic aquaculture, for example, in the northern European countries, like where we are in our area? Can we adapt sea cucumber farming to already existing aquaculture infrastructure, for example? You have the nice figure on the right-hand side that's showing an ideal integration of seaweed, fish, sea cucumbers, shellfish, and everybody living in harmony there. Can we have a system that will work for our kind of aquaculture? Yeah, for Norway, for example, this is very similar also in Iceland and Canada, and Faroe Islands. There's a salmon aquaculture that's already in place with a developed infrastructure. There's a constant supply of waste, which is the aquaculture sludge, which is feces and uneaten feed. Could this be used as a feed resource for these sea cucumbers? It's a high protein energy content in this, at least the way it's being processed now is that it's usually dried. A certain portion of this particulate matter that's being generated in the land-based aquaculture, for example, the salmon smolt facilities, it is usually dried into the powder, like what you see on the right-hand side there. And it's currently being used as fertilizer or as an input into, together with manure, to produce biogas. But it doesn't really have much of a value, and it's a very expensive kind of waste, since it has to be dried to get rid of it. Yeah, but current legislation limits the use of this as a feed for example, feed and food producing animals, like what we would do with the sea cucumber. So yeah. Yeah, so what do we know? If you're gonna do aquaculture, the success factors are to have a feed that's properly composed and available in large amounts. The right environmental conditions. We need to know the growth performance. You need to optimize that. And we need to have a rearing technology that's adapted for the sea cucumber and for the species, for each specific species and for specific life stages, because it's a complex life cycle, not like the salmon. Yeah, so we have some studies going on where we're looking at the feed composition and the ingredients and formulated feeds that we
1 minute,
make,
Jan.
and
Sorry.
the natural substrate that has been what we use so far, the sargassum algae. So we're looking into the sludge and digestibility and to see if we can increase the digestibility of sludge through processing, and in general, how does the sludge work as a feed component? Yeah. Okay, that's a last slide, but I'll just sum it up a bit. There's large biological knowledge gaps here. We don't know much about this species yet. Growth rate is slow. There's seasonal variation. We've seen that. Do they stop feeding in the wintertime? We don't know. Some have postulated that. We need nutrition for each stage. We need rearing technology that's suitable for sea cucumbers. We need to optimize water conditions, temperature, etc. The juvenile production has to be up and running, upscaled, and industrial scale, basically, and efficiency. And again, is this legislative obstacles? Can we use waste as a feed? Will there be a change in the legislation? There's bound to be disease at some point if this grows into a larger industry. And yeah, food safety issues. And there has to be a processing industry, which cannot develop until there's a steady supply of raw material, etc. And yeah, human and financial resources. Of course, even research money has to be put into research. Yeah, so the answer is maybe.
Very good. Very good answer to start with.
Yeah.
Thank you, Jan. Thank you to all the speakers in this very interesting first session, which was focused on bottlenecks to sea cucumber uses. So I just wanted to ask, I know everybody's hungry now, digitally or not, but would you like to ask some questions to the speakers, or shall we just establish a contact with them by mail for further? What would you prefer? Are there questions? I cannot see the digital questions if there are any. And in between, anybody in the room, any questions? Lars, we have nothing from the digital attendees either. Okay. Any comments? I know that it's very challenging actually to look at the sea cucumbers just as a specific or isolated resource, but the message has always been that our current sources of food are going to be soon depleted in many different aspects, starting with meat. So seafood has always been launched as a alternative, safe and nutritious option. And there are new technologies which are surging about production, which are slowly advancing in parallel to aquaculture and fisheries. So I, as a scientist personally, I am trying to be positive and optimistic that sea cucumbers could be a seafood resource in the future, not specifically only coming from fisheries or aquaculture. But I would like to ask Sandro only for his opinion on this option and on the need of having novel seafood resources in view of the general depletion of what we have and have been fishing for a long time.
Yes, thank you, Mira. Can you hear me?
Yes, perfectly.
Yeah. Well, I think, you know, talking about depletion it's important, but also we have to understand that a lot of the major fisheries around the world, that are commercially fished, there is an increasing number of stocks which are being managed more successfully. So that is what we have to do. I think, efforts have to be done into seeing that, the resources that we have are fished successfully and on a sustainable basis. And, it's a learning process. It's a lot of consultation between countries. It's a lot of, coordination and agreements between countries to do the right thing. So over the last 20 years, the number of resources that actually have been fished sustainably has been increasing. So I think this is very important. We cannot allow ourselves to deplete resources to the point that they collapse or maybe even go extinct. So I think this is an effort that we should do. However, looking at alternative sources is important. Because it provides food security. It may provide job opportunities and employment. It's a lot of good reasons why looking for diversification. It gives us the a certain security in our venture. If we are farming only one species, and that collapse, we go out of business, and so on and so forth. Now, when it comes to sea cucumber, as I mentioned, I started really working with sea cucumber, believing that it's a good species for farming. However, in the last 20 years, I've seen very little progress with most species, most tropical species, and the only very successful one as also Jan mentioned, was the one in the Corpus japonicus in China. So whether we will see sea cucumber being an important food item at the global level, I am not sure. However, being an aquaculturist, I totally agree with Jan that it's important to do these research activities. It's important to learn more about the life cycle of these species, and then go step by step. However, I must say that a lot of people have gone into aquaculture, especially in the tropical areas, on sea cucumber, thinking that this is the best solution. This is the new business. This is the new gold mine. A lot of people have gone busted. They've lost a lot of money, and thinking that this could be done on a very large commercial basis. There are stories which are successful. I can think of one, for example, in Madagascar, where there is a company that actually produces, in a hatchery, produces the juveniles of Holothuria scabra, which is probably one of the few tropical species that is actually, the life cycle is pretty well known. And they are actually farming through the collaboration of coastal communities that live in environments which are similar to the photograph behind me, which is very flat. The water comes in slowly, and they are able to put pens and grow their sea cucumber. But let's be realistic. These people are not making a fortune out of this. They're probably making some money that helps them to go by through the day and send their kids maybe to school. Yeah. But it's something to think about it. Thank you.
Yes, thank you. There is one question for you also. Ture? Yeah.
Yes, my name is Ture Carlson, and I run a fabric for prawn, producing prawns today. But we are looking for new species. And I wonder, what about pollution, toxic, and microplastic? If they are eating all the things on the ground, do you have found pollution, toxic in the sea cucumber?
From there is a working group on microplastic here in FAO. FAO is one partner of the consortium of UN and international agencies working on this. Now, I personally have never read or heard about any accumulation of microplastics in sea cucumbers. I am not quite sure if any work has ever been done. I am not aware of any. However, microplastic in sediments certainly has been recorded, and I would not be surprised that those microplastic are fed, by the treacherous sea cucumber species. So whether it's retained or not in their body tissue, I am not aware of this. Maybe it's a good and interesting area of future research. Thank you.
Just a comment on the microplastic. Our partners in South Africa in our Sun Ocean project, they have done several studies on sea cucumbers and ingestion and accumulation of microplastics. So I think we just have to face that microplastics is everywhere and in everyone soon. Thank you.
Okay, one more question.
Yes, I know that bycatch is a complicated area, but fishery management, is it, do you know if it's any project looking at how to utilize more of the different species together? I have experience in research cruises by myself many years ago. There's a huge amount of bycatch, and I think maybe we should handle it differently, the bycatch, but I'm not updated on the area, but now I had the chance to ask this question. I can add one more thing, and that's about consumers and how we want things standardized all the time. And every time I hear that someone said that this product is the best quality, it has the perfect size and perfect color, then I always think about what's the food loss, what's the resource loss. So that's also a part of it, the consumers, and how we can prepare for having more variety in our nutrition in the future.
I'm not sure if the question is for me or maybe for Jonas, or is it for me? Well, I mean, maybe I can just chip in a little bit. I mean, FAO has been working with a lot of countries that actually came back to us saying, listen, we have a problem with our sea cucumbers resources. There are no more resources, what to do. So the general advice, I mean, most countries actually close the fisheries, and, some countries close the fisheries for decades, some of the Pacific islands with some of the tropical species. So as I said, managing the sea cucumber fisheries, in a sustainable way is very, very complex, because it's a species which can be easily collected, easily stored, and it requires a lot of effort for the governments through the fisheries officer to monitor these kind of fisheries. So the best thing, what we think, is that, I mean, the communities have to, and the coastal communities, a lot of these sea cucumbers are fished by small-scale fishermen, in at least when it comes to the tropical developing countries, is to get them engaged and co-managing these resources, and helping them out to see what is the best way to what is the allowable catch, what is the minimum size, if there's any closure in the fishing season, etc., etc. So this has been worked with many countries, but as I said, they always come back saying, well, we have no more resources. We are actually closing the fisheries. And I mean, we got to a point, FAO, that we are about to finalize, possibly by the end of the year, a manual, a guidebook on a basic guidebook to say on the use of hooker diving, because there are so many fishermen around the world which are actually being killed or lose the use of their body because of bad diving practices and so on and so forth, especially because they don't find any more resources on the shallow part of the coastal areas. They go deeper and deeper and deeper and deeper, and and they dive more and more and more. So that is a big problem when it comes to sea cucumber. Now, the other thing I would like to mention, you may know that the SPC, also with the work of Steve Purcell, he actually has developed a manual on the best processing practices at the landing site, at the fisherman's level, because it's very important to be able to produce a product that is actually well prepared for the Asian market, because that will allow them to gain a better price. You know, very often middlemen and wholesalers that actually are traveling around the world, and believe me, I've seen them in the most remote areas, you know, people that were just traveling around convincing people to go fishing for sea cucumber for them. You know, they were paying peanuts simply because they would say, oh, well, you know, this product is badly prepared, is badly processed, we have to reprocess, and so on and so forth. So they were getting away basically paying peanuts and for very good products, you know. So now teaching the fisherman to produce a good product is important, so that, you know, you retain the value, you don't have food loss, etc., if this is a resource that is being exploited. Thank you. Maybe Jonas has something to add on the fisheries management.
Maybe just a few words. You know, it's completely different. You know, like Alessandro is describing, you know, what is happening in the developing world, and the resources there are really scarce, and you know, they need to have external funding for almost everything that they do. And even here, in one of the most developed fisheries in Iceland, that we are still having, you know, money issues in regards to, you know, have surveys and stuff like that. Even if we are fishing now, you know, few thousand tons of a highly valuable product. So yeah, and I still think, you know, we can manage it here, you know, but we just need to figure out, you know, at what kind of, you know, harvest rate. And the harvest rate is an issue, and maybe we are fishing it, you know, too high at the moment, and, you know, 2,000 tons, maybe it should be 500 or 1,000 tons, you know, and maybe we should look at, and we are, you know, focus on the threats themselves, and hopefully the prices are going to go up, you know. And I was a little bit as well curious, you know, because the market is, you know, we are fishing, you know, some tons, you know, thousands of tons every year, but we are fishing them, you know, all over the world. You know, we are, you know, kind of, you know, utilizing new places, like Alessandro was describing, and I can't see that, you know, the price will go up in the future. That must be just the case, you know, when they have, you know, gone through all of it, you know, like you said, you know, you went through Sierra Leone, then it was Liberia, and, you know, then it's going to be the next country, and it's going to take time, you know, for them to come back, you know. So, you know.
Any more questions or comments among the digital or physical audience? No.
Yes. If you mind, if I may ask, Jonas, what happens with all the cucumber frondosa fished in Iceland? Are they processed, dried into products, or they're frozen and exported? Is there any local utilization of the species in the country?
So there is a little bit, like you were describing. So some of them goes into tablets, you know, and they have some active ingredients, especially for the joints of people, and people are trying to put up an Icelandic market, you know, in capsules, you know, to sell them capsules, and I think the market for there. So and maybe that will be touched on later this day, you know, that's, you know, completely different market. So that could be the market, could be a market for Iceland. So that is allowed here. Some part of it is dried. I think maybe 10-15% is dried in Iceland and then shipped to China. But then the largest majority is still frozen in blocks, and then, you know, sent to China. So and we could utilize, you know, relatively clean energy here, or clean energy here in Iceland, and of course the cost of shipping them as a dry product would be much better. So there are possibilities for us here, and that also would kind of in my mind, if we do that, if we try them here, we have a better market possibilities because we can store them, I guess for several years and then send them to China. It's like almost like storing a gold. I have a dried sea cucumber in my office. I had it now for several years. It always looks the same. So we should do that. We should not, send them frozen to China. But I think that will develop, as we go along.
Yeah, just one comment. The Holo Sustain project has one of its working objectives, ordering a market research study. So it is going to be, the results are going to be available by the end of the project. So by a company that is dedicated to market research. So we will have some feedback on what is there and what is needed by consumers, also what is the interest, and there is an ongoing consumer survey about which within the project framework on which my colleague Björn Ture will talk in the next session. In the afternoon session. I suggest, because now everybody will be really hungry, that we take a break for lunch until 1:45 Central European time, and then come back. And I wanted to give special thanks to our speakers on this first session for all the shared experience and the time to talk and collaborate with us. And we are sorry we are not together physically, but we hope to keep in touch. Thank you.
Add a few comments for the ones here physically. The lunch is now actually served out in the coffee zone. So please grab your plate of, it's actually a mix of tapas today. The ones that were not able to join us for a wonderful dinner last night at Atlanterhaus Parken, they missed some wonderful Norwegian fish, but today we have a selection of some other food. So please enjoy the lunch in the zone. You can use this whole area and have a good break. And we'll be back at 1:45. Yes, thank you.
Okay, everyone, I hope now that we have recharged, we can carry on. And we have a more research session this time. This is the second workshop session. And we will start with a speaker from Sweden who is specialist in genetic sequencing and genome work. And we have invited Olga to join us today because within the interest of our sea cucumber research at Møreforsking, with a colleague, we have been trying to actually look at the genome of the Norwegian species of sea cucumber. And it has proven quite challenging in terms of methodological assays to start with. So thank you, Olga, for being with us today, and the floor is yours.
Thank you very much. Can you hear me?
Perfectly.
All right, thank you so much. Thank you for the invitation. It's really exciting. Although I know very little about sea cucumbers, and I will not be talking about sea cucumbers, I can tell you a little bit about the problems that you as a sea cucumber people can have when you try to do genome sequencing. But also I was asked about talk about the International Reference Genome Sequencing Initiative. So, and I will speak to you today at the capacity of the Biodiversity Project Coordinator at the National Genomics Infrastructure. But at the same time, I'm also scientific lead of the Planetary Biology Initiative at SciLife Lab. Just to tell you the background, what SciLife Lab is. SciLife Lab is the governmental initiative that is a center for molecular biosciences. There are two main missions of SciLife Lab. That is attracting strong researchers to already existing research environments all over the country, and then providing any researcher with a broad repertoire of different technology platforms. And speaking about the technology platforms, we enable studies of any types of biological questions, starting from small molecules and ending up with genomics and proteomics and population studies using big data and so on and so forth. We're open to any researcher in Sweden and their collaborators, but also we take in projects from abroad if there is a need for that. And we are the largest sequencing infrastructure, one of the largest in Europe, larger than us is only Sanger. And we are collaborating pretty closely with the University of Oslo, the Genome Center there. So we have the genome sequencing facilities, we have also ancient DNA facility and microbial single cell facility. And altogether we're around 80 people who are running it. And also if there is a sequencing technology in the world, we have it in-house. And also recently we work more and more with reference genome sequencing and also providing DNA extractions as a service. But now first, let me start with international reference genome sequencing initiatives before I go into the challenges. So namely, I will focus on two large ones, or the largest ones at the moment, which is the Earth by Genome project, aiming to sequence all eukaryotic life on Earth next 10 years. And also I'm representing the ERGA, which is European Reference Genome Atlas that some of you might heard about. And ERGA is nothing else than a European branch of the large Earth by Genome project that we're trying to establish. And this large project got some EU funds, and we will start working in September this year. So why do we want to sequence genomes of everything in the world? So you know that Human Genome Project, it was a 30 years long endeavor, and it resulted in tremendous changes in our understanding of human biology, human medicine, and so on. It has huge implications for patients and also for studies of human populations, and of course for healthcare. And majority of that was done due to presence of really good reference. But humans are only one species that inhabits this planet. And besides human, we have more than 1 trillion different species of life, eukaryotic life, that we know very little about. And you know, the genome sequencing is pretty expensive and unfortunately not available to any research group. And we strongly believe that presence of reference genomes for the majority of species could facilitate groundbreaking research in any aspect of biology. We sequenced humans, and just to give you a perspective, people are very curious species. We want to know what's going on around us, and very often we gaze towards the stars and we spend lots of money on discoveries, what is going out there. Like, for instance, US moon program. It costs around $300 billion in our money. So moon is no fun anymore, and now we want to go to Mars, and then it will be around $10 billion that we need to invest in that from the beginning. But at the same time, that is, at least this is science, but we also spend insane amount of money as compared to the moon program and everything else. We spend level of magnitude more money on killing one another, right? So this is how much it costs to produce weapons on our planet. And at the same time, we also have 6th mass extinction event. Anthropogenic influence on the environment has dramatically increased. The World's Nature Fund has estimated that we're losing one species every 5 minutes. So we have deforestation, we have melting ice, we have disruption of ecosystems, pollution issues, and so on and so forth. And what it means for life on Earth is that we are losing biodiversity at a tremendous rate. So the aim is that we want to study all this biodiversity while we can, and before all these species are gone, and hopefully we can also rescue some of those interesting species. So the Earth Biogenome Project, it's a network of networks. So it's a huge umbrella for many regional or species-specific or interest-specific research groups who are trying to sequence organisms of their interest. So the aim is to sequence and annotate reference genomes of 1.5 million non-eukaryotic species in the next 10 years. It's an extremely ambitious goal, of course. So the strategic goals of Earth Biogenome Project is, first of all, to understand the biology and evolution, because having so many reference genomes can help us to answer many of biological questions at a completely different scale. We also, one of the main primary goals is to, of course, to conserve and regenerate the biodiversity, but also there will be lots of deep data mining and genome mining to find the resistance genes and understand why some populations are more resistant to arid environments, some grow better in the deserts, and so on. And also because we are centered on medicine and we're very interested in our health, we also want to find out what other pharmaceutical compounds and biomaterials can be found in different organisms in the environment, the organisms that have not been studied before. And in Norway, you have your own EVP NOR that is led by Kjetil Jacobsen in University of Oslo, and we enjoy discussions with your team of Earth Biogenome Project because I think we can produce something really good together. But to give you a little bit flavor, why is it so important to have a reference genome? So here's the story of koala. Koala is nice and cuddly and beautiful, and not only good people like it, but also bloody tyrants. But genomes of the koalas, they are very puzzling, because you know that koala from the Aboriginal language translates as it doesn't drink. They do drink, albeit very seldom. And also the main source of food is eucalypti. And eucalyptus is a species that is extremely rich in poisons. So when the researchers have constructed the genome of koalas, they found answers to some very interesting biological questions. So for instance, why can koalas survive on eucalyptus alone? It turned out that they have a huge expansion of the cytochrome oxidase cluster that makes them a living breathing detox lab, so they could detoxify perhaps one of the most harsh types of poisons that are present in the plants. At the same time, they have a very specific receptor in their mouth that allows them to detect the bitterness of the leaf and also the moisture content of the leaf. So they prefer the least bitter and the most fresh and moisture-filled leaves, and that helps them to diminish the number of poisons that they consume, but also replenish some of the water that they lose. If you look in the couple of plots, the one, I don't know if you can see the mouse, but right here under the president's picture. So before in Australia, there were 4 different species of koalas. But then when men appeared, first the Aboriginal men, and then when Europeans came, the population of koalas started to decline due to hunting and deforestation and so on. So currently there are only 4 populations in Australia, and they are here in the southeast of the country. And based on the genome, scientists have designed a SNP chip, and they wanted to typify all the koala populations to see at their health state. And it turned out that the populations here in the northern, close to Queensland, it's pretty genetically stable and randomized. But if you look here as an outlier, there is a population in the south that is extremely weak, very inbred and diseased. So what went wrong here is that somewhere in the 70s, a group of enthusiasts decided to create a rescue population of koalas. Unfortunately, they were not scientists. The number of founders in this population was only 6. And unfortunately, they carried also chlamydia infection. So, and then when the numbers grew, this population was released into the wild and started to spread, carrying the inbred genes for different kinds of diseases and also infecting the rest with chlamydia. So what researchers are trying to do now, they have the genome, they know a little bit more about the biology of koalas, which species of eucalyptus they prefer, and also they have a SNP chip that can help them to study the genetic variability in different populations. So the researchers are buying private lands into the governmental property and try to create alcoves or enclaves for the koalas, where they plant eucalyptus trees that are preferred by koalas, and also they try to randomize the genetic makeup of those rescue populations. Then when the new koalas are born, they again typify them with a SNP chip and swap between different rescue populations to try to randomize the genetic diversity even further. So things are looking up for koalas, despite all the forest fires and everything else. There is a hope for this species that most likely it will survive thanks to the genome and enthusiasts and also good science behind it. But now let's talk about the challenges, why some of researchers have troubles to obtain a reference genome. And many of the roots of the problem, they are in the DNA. And the problem there is, as soon as we do not sequence human, we do not sequence a vertebrate, everything is non-model. So here is just an example how we discovered the problem. This is PacBio technology, which is mainly used nowadays for decipher the genomes, the reference genomes. And we had 2 projects, and here it would be the yeasts, different strains of the same species. In the picture number 1, at that time, we didn't know better. So we just took the DNA sample as it was, and we sequenced that. And for you who are not bioinformaticians, I just can say that N50 is a matrix telling you how complete the assembly is. So the number of contigs, around 3,000, that is pretty high. And the summary of the contigs that should correspond to the genome size was only the 1/6 of the what we would expect to see. So we had to sequence that much deeper to get a nice genome. And then a couple of months later, we got another DNA that looked different. It looked much more pure. And we sequenced that, and we can see that we could assemble 8 chromosomes plus a mitochondrion, telomere through centromere to telomere. So we got the exact length of the chromosome with its content. The N50 was the size of a single chromosome, and also the number of contigs was exactly spot on the genome size. So we tried to understand what is it, what made us to produce two completely different results. Very bad genome here and exceptionally good genome here. And turned out that the only difference was actually in the quality of the DNA. Why PacBio and Oxford Nanopore, the long-read technologies, why are they so sensitive? It's purely because there is no amplification step involved. So you extract your DNA and you just use it as a native state, exactly as it is. So that means that whatever carryover you have from the host, like proteins, polyphenols, secondary metabolites, and everything else, they can chemically bind to the DNA molecules. And then when the library prep reaction or the sequencing reaction, the enzyme comes to the screen site, it will not be able to go further. And that means that your sequencing read will abruptly stop, or the library will not be correctly formed, or your loading on the machine will be too bad, producing too little data. For people working with marine organisms, very often you have a mucus problem, which is mainly polysaccharides and different compounds involving polysaccharides, which are engulfing DNA as a matrix. And if you cannot remove it, if DNA is still contained within the matrix, many of the enzymes cannot pass through to access the DNA to do any kind of chemical modifications that are involved in the sequencing reaction. Also, there can be carryovers from the extraction reaction itself, like phenols, different salts used in different kits, ethanol and EDTA. All that can potentially impair the library construction and the sequencing reaction, meaning the sequencing outcome will be much worse than expected. Long time ago, when people could just go to the slaughterhouse and get here 54 kilograms of animal material, they could just grind it and get 2 kilos of DNA, the times were completely different. So now, because we work with non-model organisms, we want to produce reference genome from a single individual, and sometimes it's tiny, or sometimes it's a little bit bigger, but still you cannot produce thousands or hundreds of milligrams or micrograms of the DNA. So with every non-model organisms, we potentially have a challenge. If we're speaking about the experimental metrics, one thing that you can do, of course, you can record the absorption values, because the pure DNA absorbs at 260 nanometers, and these absorption metrics should be spot on. If they are deviating a little bit, then you know that the DNA sample is contaminated, and most likely it will not perform in sequencing as well as you would like to. I can actually share my slides and leave it with Miroslava or with any other organizer. This is our internal standard operational procedure, how we work with DNA before we actually measure it and size it. I can say that nanodrop should not be trusted. It can overestimate the concentration of your sample with up to 500-600 times, because it measures everything that absorbs at 260. There can be RNA, that can be some degraded DNA and so on. Whereas qubit that we are using, it binds only to double-stranded DNA. And qubit is a way better estimate for the amount of DNA that you have in the sample. Also, it's very important metrics is the ratio between concentration you obtain with nanodrop and the concentration you obtain with qubit. The closer it is to 1.5, the better chance is that the sample will sequence well. If your absorption ratios are too bad, here are the two examples of kits that you could try. The bad thing about them that they will remove up to 80% of your DNA, but at the same time, think like that. It would not be sequenceable anyway. And to make things even more complicated, that sometimes, even though you're doing your best, your absorption ratios are spot on, your qubit UV ratio is perfect, still it does not sequence. And we do not know why. I've been talking with PacBio about that for, I don't know, for the past almost 10 years. And up to now, they do not have any solution. That is extremely unfortunate, but that is the truth. And to make things even more complicated, DNA in solution behaves completely different as compared to the textbooks that you're having. And that can be a problem for the nanopore, because DNA stretches of certain GC content, they can behave differently in the solution. AT is more relaxed and loopy, whereas the GC-rich sequences produces G quadruplices or knots that can sometimes clog nanopore pores, producing quite poor sequencing results. Very shortly, example of two different organisms we sequenced. This one was very good. Here, DNA was bad. And you can also see the difference in the assembly metrics. This genome from good DNA worked perfectly, whereas this genome from bad DNA did not work pretty much at all. So to take home, to wrap it everything up, so better invest time in extractions. It will save you lots of money than trying to sequence, get better result, get back to the catching more sample, trying to get another set of extractions, and so on. Unfortunately, one can never be sure if DNA is okay before you start sequencing. That's a brutal truth. You are not alone. That because people working with non-model organisms, everybody is struggling. And we are working on it in this ERGA consortium. We are running an R&D package, hopefully to improve some of the assemblies. But there are two resources that you could check. It's a Slack channel, Atuta, or All Things Up to Assembly. They share the extraction protocols which work, and also there are some protocols that can be found in the protocol IO. And with that, thank you very much, and I'm happy to take questions if there are any.
Thank you very much, Olga. Great presentation. We already have some questions for you, but if you can take this also at the end of the session.
Absolutely.
Thank you.
Absolutely. I'm here. I'm staying.
Thank you. Give now the word to our next speaker, Ida Johanne Jensen from NTNU, on the functional characteristics of storage stability of sea cucumber tremulus.
Good. Now I hear. Okay, thank you very much for the invitation. Some of the results I will present today is from a collaboration with the the Arctic University of Norway in Tromsø, and a project there called Secure. Okay, first we all know which scene we are on. Estimates say that in 2050 we will be 9.7 billion people. Land-based resources are scarce. Food production today is already spending 75% of fresh water. So future gains would come from ocean resources, and preferably at lower trophic levels. It's of utmost importance that we also shift our diet to a more vegetable-based and also marine-based diet. Now, I'm not sure if sea cucumber will increase our seafood consumption per se, but maybe it can contribute to increasing our vegetable consumption. So that's the basis of why we are doing research on sea cucumber. Now, if you look at red sea cucumber as a source of protein, it's a very lean food commodity. It has very low content of lipids, very high content of water, and only 4% of protein. So if you compare it to eggs, it has 11% protein, chicken, cod, it's up to 20% protein. So red sea cucumber has only 4% protein. However, if we dry it, use it as a powder or completely in soup, the dried product, the protein concentration is 43%. The quality of the protein. Now, here's a fairly simplified illustration of a protein. It's built up of smaller constituents called amino acids. And every protein, being small or large, contains only 20 different amino acids. But the different proteins contain different amount of each amino acid and in different sequences. So that's how we can differentiate the proteins. And here is the amino acid profile of the sea cucumber. Now, 9 of the amino acids are essential to us, or we cannot synthesize them ourselves like we can with most of the amino acids. We have to have them from our diet. And these amino acids are the interesting ones. I'll just point out one amino acid, glutamic acid, with the ionic form glutamate, which you may know as umami. Glutamate is for umami, what sucrose is for sugar, and sodium chloride is for salt. So umami is one of the 5 basic tastes. So that's very interesting and can be a good component when using these sea cucumbers as a garniture or something to the vegetable dishes. But now if we look at the essential amino acid, the FAO and World Health Organization has established an amino acid scoring pattern to evaluate the quality of proteins. So to see how much of each essential amino acids do we need in a protein to determine like an optimal protein source to be able to provide us with all we need for maintenance and growth. So in this figure, we have compared how much does each essential amino acid provide in the based on the protein per gram protein compared to this optimal protein. And reaching 100%, it means optimal protein quality. And as we see here from the red sea cucumber, although the protein content is low, the quality of the protein is superb. Except from histidine, all essential amino acids are in the top of the scoring pattern. Also, we compare this essential amino acid content in fresh weight and dried weight, just equally. And of course, based on dry weight, we have a higher content of all of the essential amino acids. We do have to adjust for the fact that we are losing something when we dry the sea cucumbers. So then we can look at the retention of the amino acids. That means we're comparing the concentration of each amino acid in the dry product multiplied with the amount of dry product that we get after drying. And we've also found out here that the retention of each of the amino acids, the essential amino acids, are approximately 70%. So the retention is quite high, although we dry the product. But we do actually lose, of course, some of the proteins in the drying process. Okay, so I'll move to a little bit funnier part, what I do. I work with bioactive components and more particularly bioactive peptides. Something being bioactive means that it has an effect in our body beyond the nutritional effect that we want from food. Bioactive components and bioactive peptides have been documented to have an effect on our blood pressure. It can reduce our blood pressure, reduce the oxidative stress, reduce atherosclerosis, cholesterol, weight, and diabetes. And now you can buy several nutraceuticals that provide typically these bioactive components. But when we just eat the normal common food, the proteins in the food, they are broken down during our digestion so that we actually release peptides and amino acids in our intestines. And these may also be bioactive. So we can actually get this bioactivity from normal food, common food, and also not so common foods here, at least in these countries. So what we do is that we have simulated the gastrointestinal tract. So we adjust the pH according to the pH in our intestine. And we add enzymes such as pepsin to simulate the stomach phase and trypsin, chymotrypsin to simulate the intestinal phase. And then we looked at the antioxidative capacity. So you probably have heard about antioxidants and why we need antioxidants. Just by our mere existence, when we are having our metabolism and we are breathing, we continuously and unintentionally produce these toxic substances or free radicals in our body. And these can attack our DNA and our proteins and have been connected to development of different diseases. We also have in our body our intrinsic defense system, antioxidants. But sometimes if we are on typical some medicines, if we're smoking, drinking alcohol, some diets, and also other factors, there's an unbalance between these free radicals that are produced and our endogenous antioxidants. So that's why we want to have antioxidants through our food. And there are so many assays to measure the antioxidative capacity, and I've just included this one, the oxygen radical absorbance capacity assay. And what we see here on the y-axis is the amount of Trolox equivalents, or it's an antioxidant, the amount of antioxidants as a function of time of digestion. So as you see here, if you follow the light blue is the digested fresh red sea cucumber. Nothing much interesting happens like from we eat it on to our stomach phase, but then when it reaches the intestinal phase, the antioxidative capacity increases. So we actually release natural antioxidants upon normal digestion. So that's the fun part. The not so interesting part, or it's not interesting. It's just that I previously measured blueberry and saithe and other seafood protein sources, and you see that they have twice as much antioxidative capacity. Probably not surprisingly, as the protein content of cod is almost 20%, while this is 4%. So we have yet to measure also based on the dry weight basis. The other bioactivity we normally measure is the angiotensin converting enzyme inhibitory effect, so the blood pressure reducing effect. The angiotensin converting enzyme is an enzyme that, upon its activity, it contributes to increasing the blood pressure. So when we inhibit this enzyme, we contribute to reducing the blood pressure. And we measure it by the concentration needed to inhibit 50% of this enzyme. The results here, how you interpret them, is that the less amount of the peptides we need to inhibit 50%, the better it is. And we have measured dried red sea cucumber, fresh raw red sea cucumber, and upon digestion. And as you see here, the results are kind of not so optimistic as we were hoping, because compared to cod and salmon, you see that there are only 1.6 micrograms needed to inhibit 50%, while from the red sea cucumber, we need between 16 and 48 micrograms to inhibit 50%. So there was another bioactive assay that was that we were planting our feet to the ground, we can say. What we're also working on now is to look at the carbon footprint by harvesting these sea cucumbers. As I mentioned initially, we have to do something with our dietary patterns. We want to eat more seafood based or vegetable based. We want to eat lower in the trophic. but we also have to look at the carbon footprint or the environmental footprint when we harvest these new resources. So our PhD candidate now has been looking at the carbon dioxide footprint by these different aspects of the value chains, from the fishery of the sea cucumbers to the processing, the storage, and the transport. And now he has been using the transport to Rotterdam or Shanghai. So in this figure, he has correlated the carbon footprint on the y-axis with the nutrient score of the sea cucumber. I should emphasize that this is actually orange-footed sea cucumber. He's right now working with the red sea cucumber. Yes. So up here, what I've put a ring around now is the sea cucumber gutted. The nutrient scores are on the x-axis, and as you see, the carbon footprint is quite high. If we compare it to these other dots here, is herring, and the carbon footprint by harvesting the herring is much lower than the sea cucumber, with a higher nutrient score. But this is an ongoing project. It's very interesting, very new for us. And the other project I wanted to talk about was the storage stability of this red sea cucumber. And unfortunately, I have to disappoint you because we do not have any results yet. We got 100 sea cucumbers, and we want to see what is the stability when we store them either in ice on 0 degrees or at 4 degrees. So we have been sampling 6 sea cucumbers every day for 17 days, looking at the physical parameters, the drip loss, the microbial counts, and we will also look at the degradation, the enzymatic degradation, and the ATP degradation. So regarding the conclusion, I probably don't have any conclusions. I only have future ongoing and upcoming projects and hopeful collaborations. We are still very interested in the bioactivity assays. We have, as I said, just measured the fresh red sea cucumber, but for the, as was pointed out earlier here, a lot of the market is actually capsules with only dried sea cucumber. So we are about to measure these as well. Looking more into the sustainability assessments and the storage stability. And we are also now planning a preclinical studies on mice on atherosclerosis. And then I'm very much looking forward to the later presentation on consumer acceptance, because how do we get the Nordic people to eat more sea cucumbers? Yes.
Thank you very much, Ida.
3, 2, 1, 0.
Okay, again, the questions we will take at the end of the session. So I will now pass the word to our next speaker, Gisle Sostad from VKM from Oslo. We did invite and contact him to present a little bit the EFSA focal point in Norway and their functions regarding novel food approval, possibilities for exportation of novel products, and he will give you an overview of this. You have the floor, Gisle.
Thank you very much, and hello to everyone. Thank you for the invitation. The presentation will sort of concentrate on the Norwegian part of the EFSA work, but I can assure you that all member states and the EEA countries have their own EFSA focal point that will be able to sort of both present and answer the same question, have exactly the same role as VKM in perspective, in the EFSA and international perspective. So thank you very much. To present VKM.
Can you put this in presentation mode? We are seeing your current slide and the next slide. So it's.
Oh, sorry.
I apologize for cutting you.
What about now?
Yeah, now it's perfect.
Yeah, okay,
thank you.
Good. We need to take a very short glimpse in the rear mirror where it started. To explain VKM, you have to remember, and I'm sure you do, all these huge scandals in Europe and elsewhere in the 80s and 90s. It led to one of the quickest regulation works that we have seen in Europe. In a couple of years, they got the general food law in Europe up and running very quickly, and sort of a paradigm shift where we went from focus on the free movement of goods to the food safety aspect. And of course, you know also that this regulation will set out the method used for risk assessment in Europe, the risk analysis process, where we have the risk assessment, the risk management, and the risk communication, where there is a formal division between the risk analysis and the risk management. And of course, EFSA in Parma is created by this regulation, and EFSA continued to grow. It starts to work on the food and feed area. Now the novel food is also becoming bigger together with other regulated products. So what happens in EFSA? They receive mandates and they deliver opinions. Mandates from the risk managers, the commission, the parliament. They do evaluate the risks of the products, they publish opinion, and they communicate the risk together with the risk manager. So not go into the organization of EFSA, just to say that VKM is a small EFSA, exactly built up in the same way, with panels, with a scientific steering committee. I was happy to see in the last presentation on the first slide, one of the members in the VKM steering committee mentioned there. So we have exactly the same built up as EFSA. So what happens in Norway? Well, because of the EEA, Norway, they introduced the main part of that regulation into their own regulation. Mattilsynet, the Norwegian Food Safety Authority, was created together with VKM as the risk assessor. So it's exactly the same that we saw in Europe just a couple of years later. We deliver opinions as well, and we receive our mandates from the Norwegian Food Safety Authority and the Norwegian Environment Agency. And sometimes we receive a mandate issued by the two. So it's quite a holistic way also to see. And we see more and more mandates taking into account the environment and the food safety aspect, and probably in the future with the Norwegian Directorate of Health, also the human health aspects much broader than we see today. So it's an interesting way that we are working now. And we are also on the environment side, the Norwegian Scientific Authority within the CITES agreement, and the Norwegian focal point for EFSA, which we will talk a little bit more just now. We are part of the EFSA Advisory Forum focal point. We do participate in several scientific networks, and we have a role as a contact point we, as a focal point, we are here for the broader scientific community in Norway, as other contact points will be in other countries. So we work a lot of exchanging information between EFSA and Norwegian stakeholders. We share expertise, members, the different panels, both in Norway and in EFSA, share data, important. Without data, no risk assessments. And I mean, this is where you come in, really, you know, creating data for the risk assessments. We assist EFSA in developing these networks also towards stakeholders. It's a new role as of 2019. There are new procedures up now concerning the regulated products, regulated and traditional food products. So within the regulated food area, EFSA is receiving 500 mandates, 500 small or bigger risk assessments done every year. And it's 34 different directives and regulations. It's enormous. And there are 39 different workflows. Could probably be more effective, but this is how it is right now. So EFSA has a very good, in my point of view, information package on their site concerning novel food and other regulated products. I'm not sure if you are aware of that. If not, you should go into EFSA's website and have a look at all this. You will also see what EFSA is currently doing on novel food. What kind of work are doing? Are there any risk assessments coming up? So it also points toward, of course, the Commission and the list of novel food and all this that you probably know about. We use this site a lot, and one of the roles that we have is to support the Norwegian Food Safety Authority, which is the competent authority in Norway, novel food concerning. So we point to their website. Of course, there's a lot of information there, but I must say that the detailed guidelines you will find here in EFSA's webpage, application procedures, everything you need to know about that. You will have, if you go deep enough, you will arrive where you can get in direct contact with EFSA, and you will have a description of the procedures on how to proceed with importation, for example, on novel food, and also traditional food, which I think that the sea cucumber is regarded as traditional food in some countries, I guess. Have a look and see. Also on YouTube, EFSA's channel on YouTube, you will find a lot of useful videos, not only concerning applications on novel food, but also within every scientific area that EFSA is working on. So it's an interesting channel that are certainly used also from our side in the panel work that we are doing, in the information work, the risk communication work that we are doing on our side. So you can also use us as a starting point for information. That's what we are here for. VKM is then, you know, the Norwegian focal point for EFSA. A lot of information about EFSA on our webpage. We describe now also the same thing here concerning the regulated products. So we'll find information also pointing back then again to EFSA. What you also should know is that VKM, I think I mentioned that a couple of minutes ago, we represent Norway in quite a few of EFSA's formal scientific European network, and then also in the novel food network. And we have two of our staff members, Bente and Gro, representing Norway here. And what do? They follow the development in the methodology of risk assessment within this area. And we propose amendments, and we sort of exchange information between different nations on the work on novel food. So we also get information to stakeholders from EFSA via us, this network, and out here in Norway to a network. So please get in touch with us if you want to receive information about this from EFSA via the focal point. So very quickly, if you want more information about EFSA or the VKM, get in touch with us. And then you also have, of course, the national focal points in other member states that will be that has the task to give you assistance in finding your way within this. But bureaucracy, maybe it's not easy to see clearly sometimes. So we are here for you, and I hope this was an intermezzo, of course, in what you are discussing today. But here we are, and thank you again for the invitation. And if anyone has any questions, I will be happy to answer them later on in this session. Thank you very much.
Thank you very much, Gisle. There will be definitely questions. Okay, so now I will have to give the floor to myself for starting the next presentation, which is part of an example of what we are doing in the Whole Sustain project as gathering information on what is available in the knowledge field and what is needed in order to produce these final guidelines regarding innovation that will be submitted to the funding body of the project in the end. So we have carried out, in this case, this is a collaborative speech between me and Olafur, representing Mattis and Møreforsking collaboration in the framework of the project on the functional potential of sea cucumbers. So we have carried out a meta-analysis study, which was actually part of a book chapter. Sorry, I'll just move to this slide first. So this book is a book which is trying to update the field of sea cucumbers, and it was initiated by the Memorial University of Newfoundland as a project member, but they are very active in the knowledge field regarding sea cucumbers in different aspects. So they also have a poster in the poster session regarding the book, so with more details. But what I wanted to mention is that we have started, actually, we carried out a meta-analysis of what is known about the temperate and cold water sea cucumber species, about their functional properties and applications. So as Alessandro Lovatelli presented in the first session, this is the last published official guide of FAO regarding sea cucumbers and the commercial species. So there are also some emergent species were mentioned, and as it was commented in the first speech also, many of these are already established as commercial species for this new guide that is underway. So in order to decide with which species is we should focus on, we did carry out we did check different aspects. So the first one is what is the genetic information available on sea cucumbers currently. So we did check the NCBI database and also several other databases. So the Echino base, which is also a basic resource for echinoderm studies. And we found out that actually there is only 11 full genomes available. And many of these are on tropical species. So only 5 of these species belong to temperate or cold water sea cucumber species. And that For the rest of the species, there is only the basic genomic information that permits for these to be identified. That's all. We decided, we also carried out our study regarding the distribution of the species. So we decided to focus on the most widely distributed species in the Atlantic. Some of these are also represented in the Mediterranean, but are predominant in the Atlantic. So we have looked at different sea cucumbers and decided to finally work with the Atlantic sea cucumber. So this distribution map here is of Cucumaria frondosa, but also so with the color map you can see the densities, and also with Holturia tubulosa, Holturia forscali, and the Norwegian species Parastichopus tremulus. So by Norwegian I mean the species that is coastal here. It's also available, as you can see, near the English islands, and also further down it gets up to down to Spain and Portugal. So we have focused our meta-analysis study of the bibliography on these 4 species, and the study was focused on biomedical tissue regenerative potential, food possible applications regarding the collagen from the sea cucumbers, the structures and the functions of the known bioactives, what is known about the associated microbiota, and the availability of cell cultures from any of these species. So I'm going to present very briefly the first 2 points now to you. Then Olafur is going to talk about the structures and functions of the bioactives, and then I'm going to mention a few words about the associated microbiota. Actually, this is we used the PRISMA guidelines for the carrying out the bibliographic study for the meta-analysis. We have checked more than 3,000 articles, and we have found basically that most of the available information is on the tropical species, of course, like in many other knowledge fields regarding sea cucumbers, but Cucumaria frondosa is quite widely studied regarding the biofunctional potential, but there are currently no commercial or confirmed in vivo tissue regenerative applications for Cucumaria frondosa. So for Holturia tubulosa collagen, for example, there have been some in vitro studies at lab scale for on human fibroblast cultures, and also a membrane product for guided tissue regeneration. Then there are some adhesive collagen biomaterials that have been studied from the Cuvarian tubulus of Holturia forscali. You see the references from the main studies that have been selected for the meta-analysis on the slide. And then in the case of Parastichopus tremulus, or the red sea cucumber, which is least studied from all these, we have been focusing in our studies at Merforschking on the collagen, on collagen-derived peptides. So we have a work which is already out of press, and another one which is underway. There is a library of functional peptides that has been achieved after simulated digestion, as Ida discussed earlier. And then we have done mass spectrometry on these peptides, and we are trying to study them further. But some of them have so different bioactive potentials. They have antioxidant capacity, they have antihypertensive capacity, some are anti-inflammatory. So the sea cucumbers are definitely, as the bibliography shows, a huge source of bioactive compounds. And this is just to show some very good references regarding the differences and the specificities of the sea cucumber collagen, and some of the most commonly adopted extraction methods for this, which are also similar to, for example, other marine invertebrates, and also in some fish. And now I'll give the word to Olafur to comment a little bit more about the bioactives. specifically from Cucumaria.
Yep. Do you hear me? Okay. Thank you, Mira, for this and for allowing me to talk about sea cucumbers. Yeah, I come from Matís, and we are quite interested in sea cucumbers, especially with regard to the exploitation potentials and the bioactivities. Now, I will talk a bit about the functional potentials and especially about the bioactive compounds. We all agree that sea cucumbers are amazing animals. And I find them amazing because they contain really a variety of compounds with biological activities. And Ita explained very well what is meant by meant with biological activities. And there is various compounds. It's polysaccharides, it's glycosides, it's proteins. Ita and Amira talked about the collagen. It's pigments, it's vitamins, and fatty acids, phenolic compounds, all more or less bioactive. I wanted to also draw your attention to this table here. It lists up these bioactive compounds. It's from a review article from the group in New Zealand. And it shows where we can find these bioactives and the biological effects and how to extract them. So, and this article is particularly on Cucumaria frondosa, and we in Iceland we are mainly interested in this species because this is the species which we are catching. And here to the right, yes, you see the known activities of these compounds. Ita has talked about some of them. But we know that the health benefits of the sea cucumbers, they have been known for centuries and longer, for 1,000 years in China and in East Asia. But just in the recent years, recent 10, 20 years, people have been very interested in the compounds which we find in the sea cucumbers. They have been isolated and purified and analyzed, and quite a lot of scientific papers have been published in recent years on this subject. So, and this has called for further research and development. So a lot of data has accumulated, a lot of information, and this has simply made the sea cucumbers more attractive and more interesting. And this means probably that the request for sea cucumbers will only grow, and markets for new products based on sea cucumbers will be established. Now, as you learned this morning, sea cucumbers are caught. That is the species Cucumaria frondosa. It's caught around Iceland, and there are providers who sell the sea cucumbers to China. And as Jonas mentioned, it was about 15 to 20% is in sold as dry sea cucumbers in nice packages, as you see here. But most of it is sold frozen to China. But these are, you can say, these are the future products. We can buy these supplements in Iceland based on sea cucumber extracts, dried extracts, and they are quite popular in popular supplements in Iceland. And because people now know that the sea cucumbers contain all this healthy stuff, the health benefits are quite well established. But what really makes sea cucumbers so special? Well, they are a unique source of health promoting compounds. Now we know from searching for new drugs, marine environments are quite popular, but are sea cucumbers somewhat different from other animals in the sea? Well, I don't know about that, but I know that the sea cucumbers contain compounds with specific structures which we only find in sea cucumbers. And these specific structures, they contribute to the bioactive properties, and they make the sea cucumbers a unique source of health promoting compounds. So I'm going to talk about here two types of these compounds mainly, and explain a bit how they are different. The first one is polysaccharides, or are the polysaccharides. We mainly have two polysaccharides in sea cucumbers. We have the chondroitin sulfate, which is part of the, well, which we actually find in other animals, in the cartilage of mammals. We find them in a shark and a skate, in these cartilage fishes. But in sea cucumbers, they are different. You know, these are polysaccharides, so they are a chain of monosugars. But the chain in the sea cucumber, chondroitin sulfate, is branched. It has an extra sugar moiety, and the sugar is sulfated. And also concerning the other sugars, common sugar in the sea cucumbers are the fucoidans. Fucoidans are very abundant in brown algae, but in sea cucumbers they are a bit different. The linkages between the sugars is different, and also this sulfatation pattern. And this is the thing, you know, the structure and the conformation of the molecules really determines the bioactivity, and both the type of activity and the intensity or the magnitude of the activity. And the sulfatation is also important. We see that, you know, it's important regarding bioactivity, immunomodulating activity, for example. So sulfatation pattern and the extent of the sulfatation is of great importance regarding the bioactivity. So concerning the bioactivity, and I'm talking about the polysaccharides. You know, there's a lot of, you know, they have different bioactivity. And if we start with the impact on metabolic syndromes. That has been well studied, and it seems to be that these sugars have prebiotic activity, so they have positive impact on the gut flora, and through that they can improve the insulin sensitivity, and they have a positive effect on the beta cells which produce insulin. They have a positive impact on the cholesterol, and they reduce fat cell development. So I suppose they are a good slimming agent. Here we see just publications, describing these studies, anti-diabetic studies. But these sugars, they have also anti-cancer activity. It has been shown that they can reduce tumor growth, metastasis, angiogenesis, and they also, when they are administered concurrently with conventional cancer drugs, they enhance the activity of the drugs. It's a boosting effect. And also antiviral activity has been observed, and of course immunomodulating activity. And I also found a paper describing antimalarial activity. So really the activity is diverse. At the end, I wanted to mention, studies or this bioactivity. The sugars have anti-Alzheimer activity, so they are capable of reducing the aggregation and the cytotoxicity of these alpha-beta fibrils, alpha-beta 40 fibrils, which are a proteolytic product of this amyloid precursor protein, which abnormal aggregation and disposition is one of the causative agent for Alzheimer's disease. So they can disaggregate the alpha-beta fibrils and decrease this cytotoxicity, and through that they have a positive impact on the progress of the Alzheimer's. And the second compound which I wanted to talk about is the three terpenate glycosides, and especially this a molecule called frontocyte A, and this glycoside comes from Cucumaria frondosa, and it is one of the most studied compounds from this species. And the reason is that it shows really a broad anti-cancer activity. It has, it is active against solid cancers, leukemia, lymphoma, and as I said, it's a glycoside. And to the right, we see the structure. It's a very complex compound. This is a glycon moiety, and then there are sugars attached to it, and the sugars are sulfated. So the sulfatation always plays a part in the bioactivity. These compounds, they are quite abundant. That is, they are abundant secondary metabolites. So they are. It's believed that they are a part of the chemical defense mechanism of sea cucumbers. They are cytotoxic, but only they have low cytotoxicity, enough to kill cancer cells, but but normal cells seem to tolerate them. but these are really, yeah, they have, as I say, they're very interesting compounds because they have such a broad cancer activity. And a bit about that. Here are some just papers on this. They have positive impact on the progress of pancreatic cancer, human breast cancer, lung cancer, leukemia, Burkitt lymphoma, and prostate cancer. And they have other activities as well. They have immunomodulating activity, and they have also, similar to the chondroitin sulfate, they have positive impact on the Alzheimer disease and Parkinson. And regarding the Parkinson, they have these compounds, the frontocyte A, it has been compared to another glycoside, the glycoside, from the ginseng root, because that is known to have some positive impact on Parkinson. And apparently the Alzheimer, the frontocyte A is much more potent or active compared to the benchmark molecule from the ginseng root. Okay. Okay, and at the end, yeah, now Mira will continue talking about the microbiota, but I just wanted to emphasize that there are really functional potentials here, and based on that, I think the request for sea cucumbers will only grow, will only increase in coming years, and that makes us think about what we heard this morning about the just about if the fisheries, sustainable fisheries, will be compromised, and what we can do about it, and the need, for example, developing aquaculture techniques to grow these creatures. That's very important, I think. So, Mira, you will continue.
Thank you very much, Olafur. So this slide just sums up rapidly what we have found in this meta-analysis study of the bibliography regarding what is known on sea cucumber associated microbiota. So most of the 4 species that we are looking at are not so well studied. This also pointing out that the associated microbiota is very different depending on the location where the sea cucumbers are found, and even some studies have established in other invertebrates that this can be a marker for location that actually can assign or give a parameter that assigns the sea cucumber to a certain ecosystem or a certain location. But basically in Holoturia glaberrima there are 2 articles which are relatively recent. And in Holoturia tubulosa and Holoturia forscali also there is one study which covers both from 2018. Otherwise, 89% of the publications are on Apostichopus japonicus, the tropical species on which most information is accumulated so far. And in this slide, you can see an extract from from one of the recent reviews regarding natural products isolated from the studied microbiota. So there are quite a few bioactives that come from the associated microbiota with the sea cucumbers. And then I will just briefly mention that we also in this same chapter looked at the cell cultures from sea cucumbers, because as biotechnologists, we believe that the emergent methods for production that are alternative to aquaculture and fisheries could in the future gain more and more importance and be sustainable eventually when they are better developed. So we have looked at the availability of echinoderm cell cultures and sea cucumber cell cultures in particular. Basically, the information available is on primary cell cultures and not cell cultures which can be maintained during a long time. There are 2 or 3 species from which this has been intended, from the muscle or from the sea cucumbers are very specific that they can regenerate with their regeneration capacity, so they can regenerate without feeding in a relatively short period of time. They can regenerate all their organs. So from a regenerating intestine, there has been one, from an Atlantic species, one cell culture from primary cells. And also recently, through more genetic studies, some of the genetic markers about the control factors on regeneration are also being studied. So these help also to establish the cultural media that can support the growth of the cell cultures in reactors, for example, which is currently way ahead in the future, but still more and more gaining research line, and probably in Asia it's also going faster regarding meat and other cells. There has been a study which we found during this meta-analysis on combined shrimp and insect cultures. So it's a very interesting field in general. So just here the takeaway message, as Olafur already said, the sea cucumbers are, so one of the specific focuses of the whole SUSTAIN project is to look at the sea cucumbers as a novel resource for the Atlantic Ocean countries, and particularly so the Nordic region, Europe, and the American continent. So we are looking at a different type of consumer, specifically at a different type of consumer than the Chinese market. And we are looking at a high added value compounds or products, and also ingredients for novel food development. So not the sea cucumbers being sold as a whole raw material, either frozen or dried, but as ingredients in novel food recipes. So Björn Ture will talk more about this in the next session. But in this respect, the sea cucumbers have a huge potential, always considering if they can be produced sustainably. So we have submitted a project. We are trying to get funding and support from the authorities on establishing studies on the populations of the sea cucumbers and actually getting to know how many are there. So wish us luck and thank you. So that was from our presentation. I would like to ask now for questions to the previous speakers, to all the speakers from the session, probably starting with Olga on the genomic side, which I have a question, but first to the public for any of the speakers. So Olga, are you there? I cannot see you because
I'm here.
A lot of sea cucumbers on my screen.
I'm here among cucumbers.
Thank you. One question regarding the qubit, very, very specific, but is it also good enough for reading so quantifying single-stranded DNA?
No. So qubit has a fluorophore that binds to the hydrophobic part of the DNA, which is usually a double-stranded backbone.
Mm-hmm.
So it's quantifying only double-stranded DNA.
If we use this ssDNA kit, which with this one it works.
It should.
Eventually, yeah.
Okay. It should.
Cannot see if Roger is. No, currently not logged in. Sorry, but then we are in touch. Does anybody have another question for Olga on the World Biogenome Studies? And yes, Wenke? No. Okay, and so to Gisle on the novel food development, because we have received some questions. For example, I see BIS Seafood is, so Tobias is online. So we had recently received a question regarding what would be the normal procedures for trying to export sea cucumbers if the fishery is authorized. Imagine small scale or experimental fishery. What would be the first task or the first steps to take in order to get an authorization for export, for example?
Well, I will come back to that more in detail during my presentation later. But in short, you need a certificate from the Food and Safety Administration to be able to, get
this was a question to Gisle for. Sorry.
Okay, thank you very much. The question is about exportation.
Yes,
correct? Yeah,
that's what we were asked, for example, in this case.
Yeah, I am not sure really. So because this could be different from member state to member state. What is the same procedure is the approval of a novel food on the market as food or as feed. So that is sort of the common procedure for everyone. Now, the status of sea cucumber in Europe today, is it on the list on approved food or feed? I don't think so. I haven't seen it.
No.
So I think that would, in any case, be probably the first step to take. But for exportation, it would be what kind of market is it supposed to be exported to? So there will be, of course, here in Norway, it will be the Norwegian Food Safety Authority. That will be the main contact. But there should be an approval somewhere on the other end. I mean, if we are thinking about exportation within Europe, then it will be the same regulation. But if it's outside Europe, it could be something else.
Okay. Yeah, I think it's as seafood to the Chinese market, for example.
Mm-hmm.
Yeah. So with this issue, from what we understand from your comments and advice, it should be Mattilsynet first to be contacted initially and asked for further steps on this, right? And not a general application to EFSA Europe, for example, on authorizing certain species as novel food.
Yeah, we are talking about two different things.
Yeah.
The last thing is maybe the first step. I mean, to have the approval of a novel food on the European list, and that is a procedure where you or the company, whoever would like to do the application, introduce an application into the Commission, the EU Commission's central application system, and where you will have to attach a lot of scientific information. And then it goes probably from the Commission to EFSA, that will do a risk assessment based on the information that the applicant has provided. And I am not aware of any procedures going on for the moment. I know there is a couple of initiatives that we have seen. Hollow Farm, I think it's something. Yep. There are certain initiatives going on, and I think that we will soon see something coming. But I'm not sure where we are there. And in any case, to export something which is not approved in your own market would be maybe difficult.
Yeah. Okay. Thank you very much. That's helpful. Any questions to Ida? Yeah, Snorre.
Gisle, hi, Snorre. I have a question regarding the novel foods and approval of a new, or say, sea cucumbers. So I guess then if you want to get something approved, it has to be on the species level. So we were talking about earlier, we have like 90 species harvested now, and suddenly if something should happen in Europe that we all start to eat sea cucumbers, would that have to be 90 approvals, or do we need sort of a general sea cucumber approval for the market?
Well, again, you know, we haven't seen an application yet, so it's difficult to answer. But I was sort of suspecting that I would have a couple of questions that I could not answer. And what I will do, I will take these questions back to EFSA. And I will come back to Mira with the answers that I get from the Nutrition and Novel Food department in EFSA. So we can get it from the horse's mouth instead of me sort of second guessing the right or looking into the future, something which is not sure yet. Yeah.
Thank you. Thank you very much. And then we will, through the project website, also distribute this information to all interested parties. Thank you.
If I can just say one thing, is that as a contact point for EFSA, we have access to a lot of scientific personnel all over Europe. One example is that we have a system called Request for Information. It's a formal system. A couple of weeks ago, we received a formal request from an Irish, the Irish EFSA focal point. Is there any scientific work going on in Norway concerning seaweed as novel food? And of course, then we put them in contact with the Institute of Marine Research, for example, the NOFIMA, and suddenly they have a whole conversation going. If you would like to reach out to others in Europe working within the same field, please get back to us, because that is also something that we can do to connect people here.
Yeah. Okay, thank you. Any questions to Ida, because she maybe has to catch up a plane? No. Yes, Per.
Was a little bit on the.
It's not on.
It's not on.
I think no.
Maybe not. No, maybe I'll just speak loudly then. So, in terms of the sustainability assessment, you mentioned a little bit about the carbon footprint you were evaluating, and I was wondering a little bit. I was wondering a little bit about the methodology you were using to evaluate it. Do you have any answer for that, or?
Yeah, should I try without the microphone?
Oh.
It's better for the record.
Okay. I have a lot about the methodology here, if you want to discuss it more detailed afterwards. And it's not me, it's my PhD candidate who has been doing the calculation. And he has been basing it on the Canadian fishery, and then using data from reports here in Norway. And yeah, since it's not a commercial fishery going on here in Norway. And then used the most common markets, such as Rotterdam and Shanghai. Yeah, I'm not sure if I answered your question, how much detail you wanted it.
I can try to be loud. It was more, are you able to calculate more impacts? Can you categories? They don't hear, so we have to go back and forth then. Are you able to evaluate more impact categories rather than only CO2 in this?
The short answer is yes, but we have not done that. We have only looked at the carbon footprint. Yeah, but it's possible, and it should be, of course, evaluating other environmental impacts and not only the CO2 footprint.
Yeah, I can see that our colleague Leo Zamora from Cawthron Institutes has his hand lifted on from the digital audience. Please, Leo, go ahead.
Yeah, hello. Can you hear me?
Yes, perfectly.
Yeah. This is a question either for Ida, for you, Mira, or for Olafur. It has relation with
whether you can make any comments around the differences between the fresh and dry product in terms of their bioactivity, you know, either coming from the literature or from your experience. Is there any indication to say which one is better in terms of bioactivity? And then I have another question in relation with similar topic, but based on whether the encapsulation process requires a different drying method in order to preserve the activity, if there is any losses at all.
Shall I start?
Yes,
Yeah.
please.
Well, the most easy or the obvious answer to the differences between the fresh and the dried product, for instance, if you compare the protein and the peptides, they are more concentrated in the dried product. You have removed 95% of the water. Regarding if the bioactivities are affected by the drying process, I'm looking at Olafur.
Yeah, no, there is a, yeah, sorry, please go ahead. There is a company in the public who is producing capsules. So after that, we can pass the word to him and ask his opinion. Please, Olafur.
Yeah, of course, the compounds are different, and some of them are sensitive or heat labile, and they might be, you know, damaged through the drying process, but I don't have any, not really information on that, but that's just what I think.
Yeah, as we have worked with ingredients from the sea cucumber which are dried, and they are usually freeze dried, but you can also spray dry them, and we haven't seen a huge loss in the bioactivity. In freeze drying, and actually it's quite preserved. In the spray drying, you work at around 40 degrees, so there might be some loss. But yeah, if you want to comment something more, if not, I will just ask Ivan Carrera from Euroespes to make a comment regarding this. Would you?
Yeah, can you hear me?
Yes, absolutely.
Yeah. Yeah, no, just to say a simple note that, yeah, we are, in the last years, we are spending a lot of effort in try to encapsulate the extract, but what we do is lyophilized, is dry and extract the most quantity of water as possible, as much as 99%. And what we see is that it gets a more effective bioactive against certain pathologies that we focus compared with dry extract. So in that case, our method, that is lyophilization, it improves the bioactivity. But the dry extract also sustains the bioactivity of the compound. So it could work.
Thank you very much. Actually, now it was the next in the next few moments. It was preview to have the poster session, and Ivan's poster is the first one, so he can precise a little bit more on this. But I have the bad feeling I'm at an exam and I forgot the second question. So Leo, did we answer everything? Or because I think, yeah, we did. Okay. So any more questions to any of the presenters? No. Yeah. Okay. But then I will just give briefly. You know, it's 5 minutes each, 3 posters now, and then we can have a coffee break. I hope you're up for a little bit more effort. So I give the word to Ivan. Do you think you can put the posters on? Yeah. So the first poster is from Euroespes regarding their production of these bioactive capsules that Ivan started to elaborate on a little bit. So it's not this poster. This is, sorry, I'm just going. Okay, Ivan, just 1 minute. They're coming back. Sorry, the coffee was urgent, and we need some coffee now after so much information.
Yeah, for sure.
Now we are back and the poster is on. So Ivan, if you want, just comment a little bit more. You started already.
Okay, so I basically work in Neuroespis. It's a company in Spain, and what we do is we basically develop nutraceuticals that are extracted from marine or vegetable sources, and we investigate those extracts in order to try to see the bioactivity that could be could give some benefits against common diseases. So what we did in the few years ago was a study based on sea cucumber, and what I'm gonna describe in this poster is the whole process of the nutraceutical from the beginning, from the capture of the sea cucumber till the end, to the final product as an encapsulation of this powder extract, and how we develop the product as a final goal. As you all may know, nutraceuticals are food products whose nutritional functional characteristics provide benefits to help improve the health or reduce disease risk. Can be accompanied by other active compounds or exogenous nutrients such as vitamins, minerals, and other kind of nutrients that could be added to the extract or the main extract to get more efficiency in the effects. These types of products cover a wide range of possibilities, and that's why our R&D labs and departments investigate what would be the bioactivities from these active principles. Eurospis has a nutritional department, as I said, devoted to research these products and based on marine species and vegetable extracts that be obtained by the means of a non-denaturing biotechnological process, that is a lyophilization process, and that enables the preservation of the bioactive properties and their ingredients. As you may see, we've got also an industrial facility where we are able to convert the sea cucumber through powder, thin powder, that can still contain all the bioactive properties of the main source or main material through the lyophilization and freeze dry of the sea cucumber. So at the end, what we do is encapsulate the ultra-pure extract of the sea cucumber and give them to the R&D departments so they can study the effects in vivo and in vitro models of different pathologies and see what will be the effect and what will be the compounds that can be added to the main extract in order to get a powerful effect. So what we found was a really good, interesting effect on cardiovascular powder of this sea cucumber for Scalis. And that was one of the main goal of this project, was to obtain this and to have the final product that is focused on this pathology. So this is mainly what we do, and that's it. Thank you for attending.
Thank you very much. Just to point out that also EuroSpace is associated with a hospital, so they are with capacity to carry out that interventions related to this, depending on the product and the focus. Okay, now I will thank you very much, Ivan, again for being with us. I will give the word to Anna Pombo from the Polytechnical Institute of Leiria to present the second poster of this session.
Okay.
No, the previous.
Can you hear me?
Yes, absolutely.
Okay.
It's just that the poster is not on, so the next one, this one is, if you can just keep it on the screen. Thank you very much. Yes, Anna, please go ahead. Sorry.
Okay, thank you. Good afternoon. Thank you for the invitation and the opportunity to be here today. We have been working with sea cucumbers, Holothuria mamata, Holothuria forscali, and Holothuria erginensis. A few years ago, we were enthusiastic about the growth of juveniles in preliminary trials with Holothuria mamata, but effectively the growth of this species is low. Therefore, the aim of this study was to find the optimal temperature to grow the juveniles of Holothuria erginensis. In order to understand which could be the most suitable place for their production and the possible type of rearing. So we test the effect of temperature in hatchery-reared animals, F1 generation, and we use 18, 20, 22, and 24 degrees. In Raj, with triplicates, and we put also sediment in the tanks, and we fed the animals with a macroalgae supplemented with algamac. These animals grew faster at 20 degrees, but the growth was not as fast as expected. So now we are testing new diets to improve the growth of juveniles of this species with new diets and new feeding approach as sediment replacement. And we also carry out stock management studies and restocking research in a protected area, protected zone of the center of our country, Portugal. And this is, I don't know if you have questions.
Any questions to Anna? Gida? No? maybe not.
Yeah. Not question, but it just confirms how important it is to optimize the conditions, and especially interesting here with the temperature. But of course, our natural temperature would not be 20. It would be below 10.
Yeah. Yeah, I'm aware.
With 20, they don't grow fast.
So thank you. Interesting poster,
yeah.
I think.
Yes, thank you very much. Any other questions to Anna? No? From the digital audience either? No, okay. Okay, then we can pass to the poster from Memorial University of Newfoundland. Rachel, are you there?
I'm here.
Hi. Okay, so please go ahead.
Awesome. So yeah, just to reintroduce myself, my name is Rachel Morrison, master's student at Memorial University under the supervision of Annie Mercier. And this poster basically is outlining our collaboration that we have with the community of Santa Kilowak, which is a small community part of Nunavut. And we're working together hopefully to establish a commercial market in the community there. And so, as mentioned before in today's workshop, sea cucumbers are mainly being harvested to sell to the Asian seafood market. And this applies obviously to the industry that's present here in Newfoundland in the North Atlantic, where Cucumeria frondosa is the main commercial species being harvested and sold. However, it was interesting even for me to learn, because I didn't know this until I came onto the project, was that even within Canada, there's non-Asian communities that are traditionally consuming sea cucumbers. So the indigenous community of Santa Kilowak is one of those communities that is collecting a variety of benthic invertebrates, not just sea cucumbers. They also consume sea stars and sea urchins. And they expressed their interest to us about 2 or so years ago about wanting to commercialize their sea cucumber population, which is also Cucumeria frondosa. And I know we're all very heavily involved in sea cucumbers, so I don't think I need to explain why sea cucumbers are so interesting to them or why they're wanting to commercialize them. But generally speaking, there is a large interest from the community. And also they are highly abundant in the Arctic as well, as we know. So it is something that would be easily harvested and sold. And so to kind of explain our collaboration, first and foremost, we're learning about their traditional uses of sea cucumbers. So how are they harvesting? What are their practices? How are they consuming them? And then also we're getting their assistance to collect samples, and that's necessary, obviously, for our research. And so my project is where the research comes into play, but we're establishing the nutritional quality through biochemistry, and we'll co-produce and share our results with the HTA, which is the Hunters and Trappers Association. And then hopefully this will help build a future commercial development. And so the project itself was comparing 2 populations. So we collected and compared individuals of C. frondosa from the Arctic. Where you see the little red star is the community of Santa Kilowak, which is located in the lower Hudson Bay. And then we compared that population with those collected from the Northwest Atlantic here in Newfoundland. And this was to assess how the Arctic environment was uniquely influencing the nutritional characteristics of the sea cucumbers there, which we thought was very important from a marketing perspective. Maybe the Arctic is altering their quality to be more beneficial, we don't know. So through the comparisons, we found that the Arctic sea cucumbers had 4 times the amount of vitamin A. They had more essential fatty acids such as DHA and EPA. They had lipid compositions that were dominated by phospholipids, and they actually had 75% more xanthocin, which is a type of carotenoid in the female sea cucumber specifically. And you can see the DHA and EPA concentrations in the bar graphs below. And as mentioned earlier today, all of these different metrics have an array of human health benefits, and that's why it's so interesting to see these differences. And what this means to us is that these Arctic sea cucumbers are nutritionally distinctive from the conspecifics from the Northwest Atlantic. And hopefully with what we can do with this is develop maybe niche markets that can be targeted, and we can harvest maybe at lower yields but of higher quality. And that way we can try to ensure there's sustainability achieved, which is I know a major concern, especially in a cold water environment where there's slower growth and you have to take into consideration their ecology. So targeting higher yields, lower yields of high quality would be beneficial for the community there. And with that, that's basically a poster, and just to add on, just saying thank you to all our collaborators and funding. So thank you.
Thank you very much, Rachel. Super interesting. Any questions to Rachel? No? Maybe we need some, maturing of the information, but we will come back. Count on us with questions. So I don't know, are you up to the challenge for the last session? Shall we take 5 minutes break still? Yes. Okay. Leo, we need 5 more minutes to have a break, and then we will be back to you. Okay. Okay. So 5 minutes break now. Oi. Sorry, we have to go back to the presentations because our colleague from New Zealand, it's getting dark there now and he should go to sleep soon. No, Leo, sorry. Thank you very much for being with us. We really appreciate your input and we are looking forward. So you have the floor. You are muted.
Yes, sorry. Yeah, thank
Now
you very much. Yeah,
we can hear.
Thank you very much for having me. The presentations have been so interesting that it hasn't really been a challenge to stay up. So yeah, thanks again. I was thinking how to start this presentation, and I wanted to start with telling you guys that I've been working with echinoderms for almost 15 years now. It's incredible how time goes by. My major approach, my major focus has been aquaculture, which is the reason why I'm giving this presentation here, with a focus on how deposit feeding sea cucumbers can help or give more value to the aquaculture industry here in New Zealand. But before getting to the fun part, I wanted to show you where I work. So this is the Cawthron Aquaculture Park. It's located in Nelson, which is at the top, at the very top of the South Island in New Zealand. Here, me and my colleagues work on a wide range of marine species, going from marine invertebrates, fish, micro and macro algae. But the bulk of our work is on mollusks, mainly on the aquaculture of shellfish, which has been mostly enabled by a government funding, which is an strategic science investment fund that is enabling us to achieve these major 3 goals that you see here: to grow the existing industry, which is mostly a couple of shellfish species, green shell mussels and Pacific oysters, diversify into other shellfish species. You see the list, that to increase the aquaculture portfolio here in New Zealand, and also secure these industries, the existing and the emerging industries, to future-proof the industry for New Zealand. One particular project within this research platform that is managed by the Cawthron Institute, is the one that I have highlighted there, that is relevant for this topic, because it's looking into farming efficiency. So how to maximize, for example, the currently available space for the aquaculture sector here in New Zealand. And one of the ways that we're evaluating or trying to achieve that is by integrating other species with potential commercial value. And sea cucumbers happen to be one of the main alternatives for integration into the existing shellfish farming operations. So that same project generating help us get involved in the creation of this article here that you see here. In that same article, you will see the figure, the map, which shows the main areas where aquaculture takes place within the country. Aquaculture in New Zealand, it's driven, or it's mostly encompassed by 3 species. Green shell mussel being the most important. Then you have Pacific oysters. Salmon comes into 3rd place in terms of production, not of value though. And then you have abalone, or paua, as is known here in New Zealand. But one of the things that are highlighted in this particular paper is the potential for integration in all of this, for all these species of sea cucumbers into their operations. And now I will be talking about how that started and what are the potential for integration mostly in the shellfish species. There is a little bit done on salmon, but not as much as for the shellfish, for the mollusks that are listed here. So as I said, it highlighted sea cucumbers, but this is not something new. It's something that has been looked at and considered all around the world, right? From, going from places like Canada, Europe, Australia. Most of the efforts started, or the majority of the information is done or has been done on Apostropus japonicus in China, Japan. Also, a lot of studies are coming out, Holoturia scabra as well in the tropics. Quite a bit of work done in Europe. And after Jan's presentation this morning, I added Parasticopus tremulus here to the list. And I added a circle there. The circles are color coded, so basically are telling you the orange ones are efforts, either experimental or commercial efforts on integrating sea cucumbers with finfish. The blue ones are integration efforts, experimental or commercial, with mollusks. Green ones are seaweeds, and the red ones are other species, which goes from sea urchins, shrimps, other crustaceans, lobsters, jellyfish, and other species of fish. So again, it's not the integration of sea cucumbers into other species farming operations is not something new, it's not something novel. It has been happening for quite a long time, but it's relatively new within the New Zealand context. So this is our sea cucumber species here in New Zealand. This is one of many species that have been described in the country, but this is the most conspicuous and largest one, and the only one with commercial value so far. Australosticopus molles is a large subtidal species of sea cucumber. It's a temperate species, right? It can be found all around New Zealand, from the very shallow intertidal up to depths of 1,000 meters. It was introduced to the quota management system into 2004 with 35 tons allowed for commercial catch. And only recently this was increased to 100 tons, right? So this is a significant increase, although quite a small when you compare it with the fisheries in other countries. For example, what Jonas was talking about, the Iceland example this morning. It's a very conservative approach that the New Zealand government has taken, because we don't really know much about the wild populations in terms of numbers and what would be a sustainable level for capture. So it's a relatively small fisheries. I have included here two pictures, one of alive animals and the other one of the dried product. This is actually some dried individuals that I dried after quite a lot of trial and error, because it was quite difficult when I was doing it back on, this is from 5 years ago. It took me quite a while to achieve something like that, which is relatively decent. Of course, the product that is sold by the fisheries, it's processed and dried at a commercial scale. It looks much better than this. I also wanted to refer you, and I'm doing this throughout my presentation, so to some key references, because due to the restrictions in time, just feel free when you watch the video, if you want to have a look at the presentation, to go into these references, in which you will find way more detail than what I'm giving you today. And this is one of our, and at the background you have one of the latest trials that we were looking into bioremediation potential. So we have a set of tanks with single animals in which we were feeding them some special diet that they didn't really like that much in that particular trial. So this is going to be, what I wanted to highlight with this is that there were a couple of key things that happened here in New Zealand that enable a lot of research, or most of the research that has been published in the last 15 years. One being access to juveniles from the wild. So that enabled us and other researchers to do a lot of work into aquaculture production, looking at growth, diets, etc., but without having to rely on hatchery production. So that could, bypass the hatchery production and go straight into grow out and rearing techniques using juveniles sourced from the wild. And the other one was access to a very palatable diet, which turned out to be mussels biodeposits, so feces and pseudofeces collected either from mussels held in tanks. That the species here in New Zealand, they loved it and allowed us and other researchers to do a lot of the work that has been published. So I just included a couple of examples here in this slide. Also, another thing that pushed us towards looking into more deeply into the integration with green-shelled mussels here was that sea cucumbers here naturally occur associated with mussels in coastal areas, right? So they were like naturally driven or present in high numbers under mussel farms. So it was relatively easy to wanting to look into more depth into this. And there is although there is a low trophic farming activity, the potential that sea cucumbers or this species has to reduce the environmental footprint that mussel farms have in coastal areas made it quite appealing as well. And there is some literature going into detail into what sea cucumbers feeding in sediments impacted by mussel farm activities do, not only reducing the organic matter, but also enhancing bacterial remineralization and enhancing the nutrient cycling on the bottom, as well as while they're generating biomass and a secondary crop. One of the things that we looked at is how sea cucumbers, cage or not cage, will behave under a mussel farm. So because biodeposits do not settle evenly under the mussel farm, so you have zones, areas under a mussel farm with different organic loads, that means that you cannot have the same biomass or the same number of sea cucumbers placed, all the places under the mussel farm if you're using cages, right? Sea cucumbers are able to exploit and they're able to cope with a diverse organic load in the sediments, but they need freedom to move, to forage. If they're restricted and you put your cages or you put your sea cucumbers in a space that doesn't receive enough food, their growth will be compromised and they could potentially even die. And if they're not happy, these guys will go through very small holes as well. So your cage design needs to be quite good too, to contain them, right? So far, with all that information, we have been able to estimate that the carrying capacity of a typical mussel farm can be up to 15 tons of sea cucumbers per hectare. So very high densities. These guys love the biodeposits coming from the mussels. They thrive in them. They can grow in high numbers and can get big quite fast as well. But 15 tons is quite a high number. So if you go and by a very conservative 2,000 ton by hectare, which is what's coming from work in the Japanese and the tropical sea cucumbers, you can grow, and if you use only a fraction of the mussel farm space currently available, you can generate an income, at least for the New Zealand industry, of up to $25 million a year, right? So that's quite significant. And this is, as I said, having a very conservative stocking densities or harvest biomass and using only a fraction of the currently available space. Oysters is quite similar. So we have found sea cucumbers associated with sites that are in which oysters are being grown. Again, another example, filter feeder sea cucumber integration. The way that oysters are grown here, most of the farms are intertidal farms. So that means that the space available to integrate sea cucumbers into Pacific oyster farms is a little bit more restricted, because this is a completely subtidal species, so it needs to be under the water all the time. Therefore, the usable space from an oyster farm is smaller compared to a mussel farm. Although there are sites in which oysters are grown subtidally in floating baskets, right? So that will perhaps enable to use a little bit more of the space of the farm. We have been able to do growth trials under oyster farms as well, and been able to estimate the carrying capacity with a similar approach to the mussel farm trials, in which we were able to estimate when the growth becomes limited. And remember, mussels, they had a carrying capacity of 15 tons, but Pacific oysters is a little bit less than half, so around 7 tons per hectare. But again, if we take a conservative approach of 2 tons of harvest per year, we can generate a value of an extra $4 million for the industry. If we go by the estimation that the price that you can get for the New Zealand species dry product is of $350 per kilogram of dry sea cucumber, right? And again, only if we use 10% of the space available, which will be very close to the actual space that you could use for oyster farming or under current oyster farming spaces. Then the third one, which has been less studied, so we have only one published work, is with abalone. Again, sea cucumbers and abalone, they share their habitats in the wild. Both can be found in rocky reefs along the coast of New Zealand. This is a different type of integration. So abalones are grazers, right? So the type of feces and fecal material that they produce are a bit different because they feed in something different compared to filter feeders. But sea cucumbers seem to, at least this species seem to do well with when feeding on feces coming from abalone. This is a trial that was done on a land-based abalone farm. And they found that because of the diets that they were using, which was a mixture of dry seaweed, a commercially available diet, the energy available for growth wasn't enough for large juveniles. So only they could sustain growth for small juveniles as soon as the juveniles reach around 60 grams of wet weight. Their growth slowed down. So this could be a potential option as a nursery alternative rather than producing sea cucumbers up to market size. But the value for this land-based operation will be more on the waste reduction side of things rather than creating a secondary crop, right? And as a bonus as well, and I was reminded of this after Jan's presentation this morning, there has been a trial looking at potential integration into salmon farms here in New Zealand. We were able to isolate the fish waste and feed it to the sea cucumbers, but this species in particular, and I will say that will be the case for most Aspidochirotids or deposit-feeding sea cucumbers, is that they don't feed that much with sediments or with food that have a high organic content. So usually you need to, you will have to reduce the organic load. Again, every species is different, right? But for these species, we needed to bring down the organic load coming from the fish waste quite a bit in order to make it palatable, in order for the sea cucumber to start feeding on that particular diet. So the sea cucumbers were feeding on the fish waste, diluted fish waste though, and they were able to grow on it. This was a very small project, but it's the very first one that will create a baseline for future work looking into the integration of sea cucumbers and finfish here in New Zealand. And I want to leave you with one of my favorite pictures. This is juveniles created from a hat tray. And I love it because you can see the different sizes, and it's pretty good. Hopefully you appreciate it as well. Thank you.
Thank you, Leo. This is beautiful. I suggest that we take questions to Leo now, so that if he has to leave after that, he's free with his own schedule.
I'm happy to stay, Mira. So
okay.
Yeah.
Okay, thank you. Then we pass to the next speaker, which is Björn Ture with our whole sustain focus on consumer interests.
Is it on? Yes. 4 minutes. Okay. Yeah, I'm Björn Ture, senior researcher at Møreforsking, and have been given the opportunity to talk about the consumer perspective of consumption of sea cucumber in a Nordic or European context. So let's try. So first, what are novel foods? I will briefly introduce to you from a regulatory perspective and also from a consumer perspective, and then talk a bit about consumer acceptance of novel food as a huge category of food products, and then leave you with some information about the upcoming Holosustain consumer survey that we are about to launch in a minute. So Alessandro Lovatelli asked this morning, should we be working to get sea cucumber on our tables? So the Holosustain consumer survey will be a basis to say something about that from the consumer perspective, hopefully. Okay, there you go. So novel food. Novel food is any food that was not used for human consumption to a significant degree within the European Union before 1997. This is the European regulatory perspective. And similar yet different definitions exist in other markets as well, such as the US and Canada, for instance. So a novel food can be either newly developed innovative food products. It can be food products by new technologies and production processes. Again, this is European Commission definitions. Or it can be food traditionally consumed outside of the EU, but yet not within EU borders. And the underlying principles underpinning novel food in the European Union is that it needs to be safe for consumers. So safety measures needs to be made. They should be properly labeled so as not to mislead consumers. And lastly, if intended to replace another food, it must not be nutritionally disadvantageous for the consumer. So this is the regulatory perspective of novel food. In a consumer perspective, novel food equals unfamiliar food most of the time. So sea cucumber in a European or Nordic consumer perspective would be regarded as novel food to most consumers. And Alessandro also showed this morning that consumption of sea cucumber globally today is actually basically one market, China and some East Asian countries. So in the context of Europe, not much is known. We are unfamiliar with the food or species. So why what influences consumers to choose or wanting to choose novel food? So some of the key factors are marked in blue circles are from a consumer perspective, what are important antecedent for choice. So consumers would choose new or novel food from a perspective of wanting food variety, animal welfare, sustainability in the diets, and so on. These are motives for novel food acceptance. And in orange are examples of industrial motivations for developing novel foods, such as, of course, business profit, but also utilizing new resources and so on. This is a core and complex question occupying much research into food choice behavior from also from a consumer perspective or a consumer research perspective. And models to explain food choice behavior usually partition factors into three categories, namely product-related factors, personal-related factors, and environment-related factors, which I give some examples of here. So food-related factors are mostly the extrinsic and intrinsic product attributes, such as its taste and package and cost, price, and so on. And then the environment-related factors are, for instance, cultural and social, the social context which consumption takes place. And then personal-related factors are exemplified by psychological, physiological, and biological factors. And the Hollow Sustained Consumer Survey, which I will talk about soon, largely takes a psychological starting point, trying to explain consumption or attitudes toward consumption of sea cucumber in Norway, Iceland, and Canada from a psychological perspective. Some of the key psychological factors influencing novel food acceptance is food neophobia, or the reluctance to try new food. Food disgust sensitivity is a trait relevant, in my opinion, for sea cucumber in this context, and it's a trait that individuals' predisposition to experience disgust when experiencing food cues, food-related cues, such as brown apples and so on. And then there's domain-specific innovativeness, in this case, seafood innovativeness, which is also a personal trait, how much effort you put into trying and wanting to learn about new food, in this case, seafood. And also familiarity towards sea cucumber and sea cucumber consumption and so on, and also knowledge about the food. So these are only some relevant factors, and the list of categories of novel food on the left is also just examples of categories of novel food that exists and are developing as we speak. So plant-based meat replacers, for instance, and artificial meat, insect food, and so on. I don't know where sea cucumber would go. Maybe its own category. But okay. So the Hollow Sustained Consumer Survey which, as I said, is we are about to launch these coming days, I hope. It targets consumers across Norway, Iceland, and Canada, and it's a collaboration between Møreforsking, Matis, and Memorial University of Newfoundland. Thank you, Mila. And the scope is to identify and compare consumer characteristics and key food choice motives behind or across countries, and also to explore consumer responses or evaluation or attitudes towards the consumption of sea cucumber as food, not necessarily as another presentation showed us a picture with a whole sea cucumber on a plate, but as food or food stuff. Yeah. So and also to learn more about the antecedent factors. What is the what's another word for antecedent? The underlying factors that influence consumer evaluation of sea cucumber consumption. And hopefully we can say we can provide some basis for further product development. A survey is not necessarily the best methodological approach to product development, but as a starting point and basis for our own knowledge about consumer responses to consumption of this product, I think it can work out just fine. So remember this one: why does who eat what, when, and where? It's a large question, and the Holosustain survey will address the why and the who and the what. The what is, of course, sea cucumber food and consumption of sea cucumber in Norway, Iceland, and Canada. The whys and the whos are interrelated, but they reflect consumers' underlying motivations to engage in sea cucumber consumption, and the key characteristics used to explain differences in their attitudes towards, or willingness or acceptance, if you will, towards consumption of sea cucumber. So this is our proposed conceptual model trying to explain variation in consumer attitudes and willingness, intention to consume sea cucumbers. With the main hypothesis listed, it is a model under construction, but it's about to be finalized, and I'm eventually happy about it. So the next step is to collect data and bring some results to the table at a later occasion. We in the group are looking very much forward to say something to someone about consumer responses to eating sea cucumber across these countries. Yeah, as I said, I am happy to share results once they are in. Yeah, wish us luck. Thank you.
Thank you very much. Hopefully we will be able to say something in the end.
Hope so.
Okay, thank you very much, Björn Tore. So now we are, again, I remind the questions we take at the end of the session. We are going back to aquaculture with the colleagues from Gothenburg University. Christina, can you hear me?
Yes, I can hear you. And can you hear me?
Yes, perfectly. We just don't see your presentation yet.
No, it's coming here because so very nice to see you all and very nice to be in the workshop Holosustain again a year later, and so interesting to hear about all the new persons in the network and about the much more global perspectives that we have got today. It's really interesting. So now I want to leave the word over to Ellen Schagerström, who is the scientist in charge of our sea cucumber projects in Sweden, and she will tell you about what we have achieved and how far we have come, and our future plans, of course, with the sea cucumber research in Sweden since we presented last year at HoloSustain. So please, Ellen.
Thank you. So can everyone hear me?
Yes, we can. Can you pass to presentation mode? We are seeing all the slides.
I will try to do that. There we are, right?
Yes. Yeah, perfect. Excellent. Thank you.
Right. So as Christina Osnutan said, we were here last year and presented some of this, and now we're going to tell you how far we've come on that and our added projects on this. So the focus on the presentation today is going to be on the importance of good food, on the nutritional requirements for the red sea cucumber. This is part of the Circular Marine IMT project. Our aim is to develop a new circular production method based on IMT with fish, seaweed, filtrating organisms, and detritivores. The part project of sea cucumbers, which is other detritivores, of course, is to investigate the induction of breeding and develop a breeding protocol for Parastechus tremulus. We managed to close the life cycle in 2020, and we are now working towards improving on that one. We also want to develop larval rearing protocols, characterize the optimal farming conditions regarding the abiotic factors such as salinity, temperature, ammonium levels, etc. And we also need to characterize the nutritional requirements and optimal feeding protocols for different life stages of Parastechus. As Leo said previously, the food for small juveniles is one thing, but then they do seem to need more and more food. So it's important to look at each different life stage and different levels of growth to see that they get the optimal feed in order to increase the growth rate, since they are slow growing. We also want to characterize the role of the red sea cucumber in models, evaluating the sustainability with respect to nutrients in IMTA, together with fish, mussels, algae, and sea cucumbers, preferably then in RAS or semi-closed systems. So what we have in the pipeline is that we're about to develop a feed to put broodstock in optimal condition for producing high-quality offspring. Studies by Anna Pombo in her lab that we saw in the European Aquaculture Conference in Berlin, what seems like now ages ago, showed that if you enhance the broodstock feed, you will get a better output in your larvae, which is logical. So the larvae were in better shape, and you had a higher survival rate of the larvae if the mothers in particular were fed a better feed. We also want to develop feed for juveniles, and we want to base this feed using waste from aquaculture, such as algae, bivalve, and fish waste, to optimize the growth rate and survival for them. And this is also in order to combine them with sort of using the waste from aquaculture. We also need to determine the physiological responses and tolerance limit to water parameters for the establishment of optimal protocols for the co-culture rearing, so that we know which species to couple them with and which intervals of different parameters that they can be kept at, reducing the amount of stress which inevitably leads to diseases. We also need to do further studies on feed and feeding for all larval stages and in situ observations of populations to learn more about the ecology of this species, because there's very few papers published on the natural ecology of this species, since their distribution tends to be a bit on the deeper side. So this fall, I have two lovely master students that are going to come and work with me and help me. The first student is going to focus on the feed and nutrient uptake. This is based on the pilot studies that we presented here last year. And we will make a feed with a mix of algae, bivalve feces, and fish feces in separately and in combinations. And we will analyze the ingestion rate, the feces production rate, food conversion efficiency, apparent digestion rate. And we will also look at the oxygen consumption and energy budget for them during this. And this is my student Kelly Johansson that will perform these studies. Then we have the physiological studies that we also presented here last year. And we have developed this respirometry design to use the oxygen consumption of the sea cucumbers as a proxy for stress. We have already tested the stress levels of different temperatures with the species. And we are now going to move on with the salinity, different levels, to see what's the lowest salinity tolerance of this species, to see if they are affected at all by pH, the ammonium levels, and also at what the lowest oxygen saturation level tolerance. This is Rebecca Bassman, another master student that will perform these studies. She will also be looking at the effects of stocking density on growth. There has been some publications looking at where you can see at stocking density of sea cucumber seems to have a sort of peak value where if you have them too highly stocked, they actually stop growing or actually reduce growth. So we need to look at this in order to establish an optimum density for growing conditions. And then we have the larval feed with where we're working on the entire life cycle. And so this season, if all goes well, we all know what it's like working with animals. For the auricularia or the mid-auricularia stage, we are investigating an optimal feeding regime, looking at whether we need to feed once or twice per day. We already have established the amount of feed, and now we need to look at how to best give it to them. For the late auricularia larvae, we are going to look at some methods of initiate the metamorphosis into the next stage, the doliolaria. And there we want to increase the number of larvae that goes through the metamorphosis. We also want to increase the larvae that actually exit the metamorphosis through the pentacula stage. And again here, we need to discover some sort of chemical cue, I think there is, to settlement inducement. Some papers suggest that this is caused by different benthic microalgae. So we're going to look at what local species could be to induce the pentacula larvae to settle. We also need to find a good feed for the settled larvae so that they have enough of this. There are several papers showing what is done in other species. We will try to see if the usual method goes also for this species or if there is a local tweak since we're in a different region. We will also look at the juvenile growth rate of this species. We will look at the juvenile feed because, as we saw before, the growth rate depends on having good enough feed. And we will, of course, also investigate the juvenile mortality rate and see what size will be the safe size. And if we, through feed and through all these abiotic parameters that we have discovered, can reduce the mortality rate of the juveniles. Our aim is to increase survival to around 20%, which I've seen done in other studies. It is perhaps optimistic, but that's our target goal for this. We hope to reach that, not perhaps this year, but in the near future. We will also perform some field observations on the ecology. The red sea cucumber lives rather deep on soft bottoms. Where I am located at the Kristineberg Marine Station on the Swedish west coast, there is a local population in the Gulmar Fjord, which lives at a rather shallow depth between 60 to 70 meters, and they do tend to migrate upwards in summer during the spawning season. So using my lovely little ROV, I will investigate this population and look at the size distribution in the population and see if it is a viable population with active recruitment or not. I am very interested in looking at the natural population densities to see the spatial distribution. And we also hope to see if we can detect some sort of aggregation behavior if we are there and observing during the spawning season. It would be most interesting. And that's pretty much it from me.
Thank you very much, Ellen and Christina. Okay, so there are two more brief presentations in our session, and then we will open for questions. I give the floor to Wenke to present how sustained partner Okupe Blue Legacy and their activities related to promotion of novel products.
Yeah, thank you. Thank you so much. Glad to also have the opportunity to say a few words here in this wonderful audience. And now we can lower our shoulders a little bit. Now it's less scientific, I promise you. And I think it's about time that we show a movie. But first of all, since 2016, I'm being the manager of Blue Legacy, which is a marine and biomarine cluster with about 56 partners now from the whole marine and biomarine value chain. I will come back to that. And our aim and target is to increase the value of marine wild caught raw material, including residual raw materials. But first, I would love to show you a movie, which is sort of telling us a little bit maybe the reason why we are here, why we are focusing on these wonderful resources that we all care so much about. So let's run the movie. Oh, no. Do you have to push play at your side? Yeah? Sound.
We have lived from the ocean for generations, fishing cod, shrimp, herring, and mackerel. Now, we are developing science and technology to help us harvest species such as zooplankton, mesopelagic fish, kelp, and sea cucumbers. Norwegian fish and seafood are valued worldwide. By the year 2050, more than 9 billion people will inhabit the Earth. In order to feed the growing population, food production will have to increase by 60%. Healthy and sustainable food from the ocean is part of the solution. OECD projects that ocean economy will double in size by the year 2030. Norway, as a leading fishing nation, should take an active role. We are creating value on land and in the sea in order to develop valuable products for new markets. Raw materials from the ocean provide food, marine ingredients, and medicines, contributing to value creation and new business development. Let's work together for continued growth.
I just love this movie, and it gives me a feeling of being proud every time I see it. I've seen it like 50 times at least. But anyhow, we know there's a growing population. We need to feed the world. How can we do it in a sustainable manner? And there are both challenges and opportunities, as we know. And for our cluster and our stakeholders in Norway, it's about collaboration actually throughout the whole value chain, and collaboration between authorities, industry, and academia in order to optimize and better use these food resources and also create new value from them. In our cluster, we are what we say value chain organized, and we have members, national and international companies from the whole chain, from catch, processing, and offering finished products to the plate and as dietary supplements, and actually also partly to pharmaceuticals. From the start, the cluster had a very clear ambition that we should utilize 100% of what we take out from the ocean. So that has been a core for us. We also collaborate in order to innovate and be able to lift new